Good morning, everyone. Welcome to Spain. Welcome to Seville. Thanks a lot for coming to this European and quite broad and big and wide event that we are organizing. Thanks a lot, because without your presence, it wouldn't be possible. My name is Santiago Cuesta. I am the General Manager of ICAMCyL Foundation and the General Manager of the Iberian Sustainable Mining Cluster. The ICAMCyL Foundation is an innovation procurement excellence research center, which is part of the smart specialization strategy in Castilla y León. And among the different activities that we are covering, energy, social innovation, advanced materials, etc., we are focusing, and we were raised to boost the raw materials initiative and the recovery of the region of Castilla y León for the green transition and the just transition. And since now about 7 years, almost 7 years that we were created, we have been having and promoting a relevant presence in Europe in the context of raw materials. We are very active. We are coordinating different European projects, and here with us we have very long-term, very nice long-term collaborations and cooperations that we are here together. And one of our initiatives was to organize this big clustering event in the context of another national activity which is happening now in Seville, which is the Metals and Mining Hall, the MMH. In addition, as I said, I am the General Manager of the Iberian Sustainable Mining Cluster, which is a national cluster where ICAMCyL is taking part. And this big national cluster is part of the main ecosystem of business catalysis of Spain across the full, or involving all the value chain of raw materials. We cover from sustainable technologies, detection, geophysics, satellite, up to pure mining extraction or even mining trading and raw materials trading, and investment, etc., etc. The cluster now is about 90 companies that we engaged. It is still getting or growing and growing and growing, getting bigger. And also, among the companies and the institutions that are cooperating with us, we are now about 120 members, which is a big size compared to the Spanish side of usually the innovation associations that we have in our country. Again, the cluster, the Iberian Sustainable Mining Cluster, is every day getting more attention in Europe and more attention in the business of raw material sector. And that's why during this week, these 2 days, we decided to synergize both institutions to organize, thanks to your presence, this important raw materials clustering event. We are gathering 27 European projects across the value chain of raw materials, involving processing of technologies and advanced technologies for processing of raw materials, advanced technologies for recovery of raw materials, thinking in the importance of the circular economy, traceability of raw materials, thanks to the project MadiTrace, which is one of the projects that is hosting this event, together with us, of course, but we are really very grateful to BRGM, which is our coordinator of this project, and to the European Commission for using these funds for really making this possible. And also detection technologies. And the other project that is hosting this event is S34E, which is coordinated by University of Porto, and is one of our main projects in the community that is really touching forefront technologies for advanced detection, satellite detection, exploration of raw materials. So that is the main reason why we have organized the sessions that you will see across the day, along the day, in 4 blocks that some of them will run on parallel because of the time constraints and because of the size of people. We have organized it with, or we have tried to organize with a roundtable discussion, so everybody will be able to participate. The roundtable will be moderated, facilitated by different people. And very important, we will engage the most important European projects per thematic that we have detected that are currently in Europe running and creating an impact at European level. The idea is that, or think that this workshop is also informal, so you are welcome to pose questions, to intervene, to discuss with the panelists. We have organized it also in a way that we will be hosting a keynote lecture per session, I mean per thematic. We have selected forefront companies or professors that are working in the thematic that at the end is clustering with the different European projects. And as you will see, the idea is that the time will be spared in a way that we can also cooperate and exchange opportunities and activities among us, create synergies and create links. As you will see also, we have organized it in the program in a way that we are touching also an important point, which is the framework or the current political framework of the Raw Materials and the Raw Materials Act in Europe. All these projects will never be possible without the influence and help and really boosting activity of DG GROW and the European Commission. And that's why we have today in remote, hybrid mode, Martin Lans from DG GROW. He is going to explain us which is the current status of the Raw Materials Act. No? So the Raw Materials Act was approved in March this year, and the idea now is to see how we are going to implement and what are the consequences, the good consequences, and also the framework consequences for our companies, for our countries, and also for us, for those that we are procuring innovation. No? How many projects are coming, how many budget, how much budget, what are the opportunities that at the end we will have in Europe to really meet, because we are the elements, this is very important, that the people that are here today, we are the instruments to really make true the Raw Materials Act in reality. Not in the offices of Brussels, not in our parliaments. Here we are the ones, we are the companies and we are the researchers and we are the innovators and technologies that at the end are every day making this possible. In addition, as you will see also in the program, tomorrow we have a very interesting day devoted to companies. Again, in the value chain, we are trying, and this is very important in Europe now, to have the concept of the quadruple helix. I will speak in my presentation later on about the importance of the ecosystems of innovation. Raw materials are impossible under Raw Materials Act, but raw materials are endogenous resources. The Raw Materials Act will never be possible to be real if we don't create European ecosystems of industrial innovation. And this is a key concept. And here again, we tried to reflect that concept in our conference, making the possibility to high-tech companies, deep-tech innovators, to present tomorrow their innovations across the value chain of raw materials, the different projects and the different activities. For that, we will have this elevator pitch of different companies, and technologies, companies, opportunities will be raised tomorrow along the morning. In addition, as you see in the program, around noon, we have organized this part of the future which is coming, which is a B2B activity to go for new European projects and to go for new activities together. I didn't want to miss the opportunity of having here about 90 persons which are in our community of raw materials. All we are in top institutions in Europe, top companies, all we coordinate European projects. So it's the best atmosphere to brainstorm the new ideas that probably will be founded, or we will try to present to be founded, to really make possible all the objectives of the Raw Materials Act. So tomorrow we will have that particular session, and please, it will be very informal. It will be animated by different companies and also from the different teams from my cluster and the Foundation ICAMCyL. And again, will be informal, but please participate, because I am pretty sure with the persons that I am seeing in the audience that I know you, and we are cooperating in different projects, that very good ideas will happen, and we will organize for the future and for the next future. Last but not the least, is our intention that this clustering remains for the next years. The idea is to organize this event in a successful way, that we repeat it from the next years, from now on go on, and in synergy, of course, with all of you. Again, really thank you. Thanks to the European Commission and thanks to our governments for supporting us, because we receive different sources of funds. And of course, thanks to my team from the two institutions that are making also possible all the organization. Welcome. I hope that you enjoy the stay and the interactions, and thanks again for being here. Now I think we have Martin Lange is already online. So Martin, can you hear us?
Yes, I can. Good morning from Brussels.
Thanks a lot, Martin, for taking the time for being with us. We are really grateful. Please, the floor is yours. And introduce us. Where are we now with this Raw Materials Act? What things are coming? And what are you expecting from us? Because here, as I said, more than 27 European projects in raw materials are clustered for thinking also on new ideas. Martin, the floor is yours. Thank you.
Well, first of all, good morning again from Brussels, and thank you again also for inviting me to this important event. I would have liked to be personally also with you, but as you can imagine, these are also very, very busy times here in Brussels. We have quite some activities ongoing. Just today, for example, we have another meeting of the subgroup of one of the subgroups of the Critical Raw Materials Board. We are very busy also with assessing all these strategic project applications that we have received end of August. So it was unfortunately impossible for me personally to come, but still already now I would like to wish you all the success also from our side for this important clustering event. And as Santiago already explained, you are all extremely important members of the communities, and you are the ones who are going to help us in implementing also the Critical Raw Materials Act. So I have prepared a few slides that I would like to share also with you in order to give you a bit more of a background. What are the measures foreseen under the Critical Raw Materials Act? And I hope that you're also now able to see those slides in the room. So this act is a result of some deep changes that have taken place during just the last few years. If you remember the times, specifically how the world looked like before the pandemic and before the Russian aggression in Ukraine, you will remember that we have been living in a globalized world. In the meantime, things have changed tremendously. We have seen, because of these events, tremendous disruptions of supply chains. Industry has struggled during these years in maintaining production, maintaining access to very critical components that are needed for production, and most importantly also access to raw materials that are needed in order to also sustain our economy. That is why the European Commission had proposed in March 2023 this new regulation concerning the raw materials, and it has been also adopted and entered into force within 1 year, which is according to Brussels time standards, really a tremendous achievement, which would not have been possible without the broad embracement of the co-legislators from the European Council and the European Parliament. So I think here there's a broad consensus that this is a very, very important piece of legislation that we are going to work on in the coming years. So the Act itself is built around 4 different pillars, where we are trying to address all the different issues that we have seen being problematic in the last years. We are foreseeing a certain number of measures to strengthen all stages of the European critical raw materials value chains. Then we are also foreseeing measures to improve the EU capacity, specifically to monitor and to mitigate any kind of risks in the future that might happen related to the disruption of those supply chains. And one of these measures is also the diversification of imports that we still have and will still have in the future regarding critical raw materials from third countries. And then also a very important element is the improvement of the circularity and sustainability of the raw materials. So all these measures foreseen in the Critical Raw Materials Act are related to one or more of those pillars here. And how important this is actually shown by an exercise that we regularly carry out every 3 years, where we look at the so-called criticality of a number of raw materials. So the last exercise, we carried out this exercise for more than 80 raw materials in order to determine which of them are considered critical in terms of economic importance and in terms of supply risk that we have in order to gain access to those raw materials. And you can see the result of this exercise listed here below, where we have defined, according to the Act and according to a predefined methodology, 34 raw materials as being critical. Now, the criticality assessment always looks to the past, about trade flows, what has happened over the last 5 years in terms of time span. But there are a number of those raw materials which are actually absolutely crucial in terms of supply that is needed in order to have access to strategic technologies and to make use of those technologies. And moreover, because of the importance of those technologies in the coming years, it is expected that the demand for those raw materials will also outstrip the supply that will be available. And therefore, those critical raw materials, it's a subset of those critical raw materials, 17 in total, that we consider really strategic. And those strategic raw materials are listed here also below in green color. And not surprisingly, these are typically materials that are needed for batteries, for example, for permanent magnets, important for electric mobility, for example, and in traction motors for wind turbines. So this just as a background information so that you understand also where this list of critical and strategic raw materials is coming from. Here are some of the results of this criticality assessment, where you can see also the geographic dimension of this. And this is, of course, largely political. As you can imagine, any kind of disruption of supply from specific countries could also cause significant problems for us in terms of access to those raw materials. And you can see, for example, we are highly dependent specifically on countries like China as it comes to the access to rare earth elements, for example, to germanium, and so on. Unfortunately, at this moment in time, our own EU capacities are not sufficient to compensate for those kind of potential disruptions. So also this is part of the exercise that we have carried out in terms of extraction and in terms of processing. Of course, there is and there are already activities ongoing in our member states, but certainly there's a lot of room for improvement in that respect. Also, room for improvement is regarding the recyclability of those strategic raw materials. And you can see here that, of course, for some of them, the more mature ones like copper, tungsten, we already have quite some technologies and industry that is, of course, active in the area of recycling of those materials. But there's also here a lot of room for improvement for many of those strategic raw materials where we have actually, in certain cases, even none of them being recycled. So the Critical Raw Material Act also therefore sets us some targets, very important targets where we want to go to in the future. And specifically already as a first step, it is looking to the year 2030, which is actually not so far from now. So in 5 years' time from now, we have certain benchmarks that we wish to achieve. And this is, of course, only possible if we are quick in implementing all these measures that the Act foresees. So more specifically, when you talk about the annual EU consumption, we want to cover 10% of this EU annual consumption by extracting these strategic raw materials ourselves in the EU. We want to also increase our processing capacity and refining capacity of those strategic raw materials such that we can cover 40% of the annual EU consumption with our own production, and at least 25% of the EU annual consumption of the different strategic raw materials should be covered by recycled strategic raw materials. Moreover, in terms of diversification and reducing our dependencies on third countries, we think it's important, and the Act also actually sets us the target, that not more than 65% of the EU consumption of each strategic raw materials should come from one single third countries in order to we are not too dependent on these third countries. The Act proposes several measures, important measures, in order to address these targets. But of course, probably the most important measure are the projects. So these are, of course, projects such as you have now gathered together in order to address also many of these technological challenges, but also very concrete projects that help us to achieve the 2030 benchmarks already. And this means that these strategic projects that we want to set up can apply to a call for applications that we have launched. And these strategic projects have to fulfill certain criteria in order to be selected as being strategic. So first of all, these strategic projects need to demonstrate that they can contribute to the security of supply that we have set forward in the Act. And here specifically, the contribution to the 2030 benchmark. So we expect these projects to already have very concrete output and production started up by the year 2030. Of course, these projects also need to comply with all the ESG standards that we think are important and that are also enshrined in the Critical Raw Materials Act. So we want these projects to be implemented sustainably. They need to be, of course, technically feasible. Also here, these technologies should have already been demonstrated in relevant environment, for example, and also there should have already been enough feasibility studies in order to receive this label of strategic project. And last but not least, we also want these projects to be either of cross-country benefit for countries, for projects that are located in the EU, or if they are located outside of the EU in third countries, specifically in countries that are in developing economies, we expect them to also add value in those third countries. The benefits are clear. I think specifically we want to make sure that these projects can go ahead quickly. If you are recognized, if these applications are recognized as strategic projects, they will receive under this EU regulation a priority status whenever there's a possibility in national law, more specifically and in particular regarding the permitting procedures. So the Act is setting a maximum time that the permitting process may take in those EU countries. For extraction projects, this is 27 months, and for processing and recycling projects, 15 months. We also will make sure that these strategic projects have access to financing. We will make sure that these projects can discuss their financing needs with all the relevant financial institutions that we have in the EU, but also in the different member states. To that end, there is a specific subgroup of the Critical Raw Materials Board that will look at each and every of those strategic projects in order to support also the needs and make sure that these projects can get a kickstart in terms of whenever there's financing needs for them. The call for application has been launched at the same day that the Act entered into force, end of May, and we have gathered all the necessary information for applications on this website, including application forms, guide for applicants. We organized an info day, and there's a relevant set of frequently asked questions. So you're invited to also have a look at this website in case that you think that your project ideas could benefit from the strategic project status. The first cutoff was already end of August, and here we have been, modestly speaking, overwhelmed by the number of applications received. I think that this was far beyond our expectations. So in total, we have received 170 applications at this first cutoff, 124 of them from projects in the EU and 46 outside of the EU. And these applications cover all strategic raw materials that the Act defines, and specifically also you can see here, according to the project types, we have received 77 applications covering extraction, 58 applications processing, 30 applications recycling, and 5 applications also addressing the substitution of strategic raw materials by replacing them with innovative alternatives. So here the assessment is ongoing. we are, as you can imagine, extremely busy at the moment in getting this organized. We are also assessing these applications with the help of experts who are going to look at them and will give their opinions, analysis of the different applications so that the Commission can, in the end, take a decision and propose a first list of strategic projects to the Critical Raw Materials Board. And following a discussion at this board, where we hope that we will be able to have this list probably around March next year. So there are also other important measures, of course, that the Critical Raw Materials Act is putting forward, including also exploration. So there is the mandatory element of national exploration programs that need to be drawn up by the member states in order to increase our geological knowledge of the potential that we have within the EU. And also here, we are currently discussing with the member states on these national exploration programs in order to get together all the necessary information related to mineral mapping, geochemical campaigns, geoscientific surveys, such as geophysical surveys, and so on. So also here we had just a very first meeting of the Critical Raw Materials subgroup dedicated to that, and I think there's promising progress. Of course, these criticality assessments that I mentioned in the beginning of my presentation will be continued. So the Act obliges us also to continue with this every 3 years, but we want to go beyond this kind of regular assessment. I think the ambition that we have is to go more towards a kind of a real-time monitoring of the different important elements related to this criticality assessment, such as the monitoring of trade flows, looking at what happens with demand and supply, so that specifically we could think of setting up some early warning system in case of disruptions of one or the other kind, as it comes to the supply and the availability of those raw materials, so that we would be able to actually intervene much quicker than in the past, than, for example, what happened during the pandemic, so that we can also take the necessary measures in order to mitigate these kind of potential disruptions. There's also something that can be done on the member state side and on the company sides. I think it's important to have also certain elements related to risk preparedness, stress testing that the Act foresees, also the coordination of strategic stocks that exist in some of the member states is one of the elements that the Act is foreseeing, as well as a voluntary joint purchasing mechanism that will be set up. Finally, and this is also extremely important, is of course the element of sustainability and circularity. So I think also here the Act sets, as I mentioned earlier, the very ambitious target of having 25% of the EU annual consumption covered by recycling for the different strategic raw materials. And if we want to achieve this, there should and have to be national measures on the circularity, increasing the reuse, collection, and recycling, also use of secondary raw materials, the development of new type of technologies that we can use in order to increase efficiencies, but also maximizing the potential from still existing extractive waste facilities that we have in the EU from old and previous and closed mining activities, for example. There are some specific elements regarding permanent magnets and the recyclability of those permanent magnets. And then we have also certain other activities that are foreseen and will be launched in the coming years, such as the recognition of certification schemes that can certify the sustainability of critical raw materials. And then at a later stage, also we could, and we have been empowered by the Act to set also information requirements, for example, on the environmental footprint of all kind of critical raw materials that are placed in the EU markets. So just a very short, to wrap up a little bit, I already mentioned that we're working closely together with the member states in the Critical Raw Materials Board, also in the different subgroups, including with the financial institutions and the financial subgroup. But on top of it, of course, there's a very important international element not to be forgotten. We are developing strategic partnerships with resource-rich third countries. At the moment, we have 14 countries with which we have concluded also memoranda of understandings that are foreseeing also specific roadmaps that we will develop in order to also diversify and increase our supply from those specific countries. This is also important element. We very much encourage all kind of collaborations with those third countries in order to strengthen our ties with relevant players in those countries. So that is all from my side. If time allows, I'd be happy to still take, of course, some questions, Santiago, from the room.
Thank you very much, Martin. Well, I don't know if there are some questions in the audience, taking profit that we have Martin with us. Please.
Hello, my name is Maria Magdalena Holmgren Nilö. I work for a Norwegian Climate and Environmental Institute, and we just heard the news that Norway signed an agreement with the United States. So my question would be, in securing the processes and the value chain for diverse critical raw materials in EU, how do we compete or work together with United States? Thank you.
Yes. This is, of course, extremely important, not to look only at the resource-rich third countries, but also with like-minded countries who are facing the same problems as we are. Here we're talking about USA, of course, but also other countries like Japan, with whom we are also exchanging on a regular basis in other fora that we participate in. And here I can specifically mention the Mineral Security Partnership that is meeting regularly. And we are also building up on the basis of this MSP a new forum where we invite also third countries, projects in those third countries to present so that we can help them also with specific financing. So there is an exchange, a regular exchange of information and also collaboration with all the colleagues in those like-minded countries, including the US. I'm sorry, I cannot hear anything. Now it's back.
Yeah, I was saying, now yes, thank you. One of the microphones were not working, Martin, sorry. I was saying, thanks a lot, Martin, for the answer. I was asking if any other question, but I think the audience's side. It was pretty clear. Thanks a lot for the presentation. Looking forward to meet you soon in the Raw Materials Week. I think all the people that are here, we will be hosted by you very soon in Brussels. And I think it's the common feeling, no, that we are very enthusiastic about this new, about the horizon that you are presenting to us and all the efforts that the European Commission and the raw materials community is doing all together. So a big applause to Martin. Thanks a lot. And now it will be my turn, I guess. So I will give you a short view about the opportunities and one particular perspective that we have from our cluster and our foundation, particularly about what I mentioned in the beginning of the introduction, to this event, the European innovation ecosystems, or the ecosystems of innovation, and how they relate to raw materials. Because we believe that it's the only instrument really capable of making true this raw materials activity under Raw Materials Act that the European Commission and all our member states have launched. I jumped about my presentation because I used the introduction to introduce myself. I will very quickly mention the importance, or some of the highlights of the importance of the Raw Materials Act, also related to today, to our event. Already Martin explained it, but I want to focus your attention on some of the targets that the Raw Materials Act have. It's very important that Europe must really cooperate in order to make possible the raw materials. We need really to cooperate with other countries. This is also one of our key messages that we are working in our cluster. And that's why, as you will see later, in our innovation ecosystem that we are promoting at the European level, because it's a matter of joining forces across different countries and different mining regions, we are really taking very seriously the investment world. We are creating an investment platform. Without investment, there is no possibility of really deploying and launching critical raw materials project. And in that context of investment, it comes the cooperation with other countries. So Europe is rich in raw material resources, but is not as rich as other countries like South America, like Africa, etc., etc. And here comes also the next roundtable that we are going to host about geopolitics. We cannot, and we are forgetting, or sometimes we are focused more on the development of technologies, the development of activities, mining technologies, but we are forgetting two important points: investment and the geopolitics of all this game. And without geopolitics and trade, this is an important point, we cannot achieve the objective that Ursula von der Leyen launched about having a critical raw materials club of countries that we are cooperating together. And this is going to be also very important because in order to cooperate with that countries, we really need to create these local establishments, because at the end, raw materials are endogenous resources, and the rich is created where the raw materials are. But if we are commercing raw materials from other countries, we need really to have in our floor, in our grounds, the industry to transform. So it's very important that Europe must quickly create this resilient industrial ecosystem, but with keeping in mind that we cannot do alone. And that's why today we will have also these discussions about strategy, geopolitics, stockpiling. I will launch also the question of strategic stockpiling. This is something that other governments, other countries like Japan, United States are doing, and we are not doing in Europe. There are many reasons why, but it is here the question. And also, we must really create another target that is in the Raw Materials Act, which are the strategic raw materials partnerships. Again, the way that is conceived cannot be understood without the cooperation between countries, and again, without the cooperation between the regions. Because in the reality, if the region where the raw materials are, where you want to build a mine, if the region is not cooperating, if the town is not cooperating, if the society doesn't accept the raw materials, then all this act is meaningless. We are not going to be able to create the act and to pursue the act. For that reason, in addition to all the targets or the technological targets that the Raw Materials Act has as milestones, and all we are cooperating in new technologies for processing, for exploration, etc., it's very important that we also focus on a way of achieving some of the other important targets and activities that are going to happen. And the way that we are working on that, as I was anticipating, is this creation of industrial resilient, because we must create it in a way that these industrial ecosystems are somehow invulnerable to shortages of supply, of geopolitical problems, wars, etc. And the way of doing that is with this international cooperation, but with a very good design of how we understand the raw materials value chain. I would like to discuss with you this nice picture that we used together with Enable company. They will be tomorrow around, or even today. They are also in some of the European projects that we have. We created this for the analysis that we are conducting together for the European Investment Bank. We are conducting a private analysis for understanding the full value chain of raw materials and where it's important to invest, or where the instruments or financial instruments may invest. And here comes what we call the valley of death. So the raw materials value chain, all of you know very well. Martin just also highlighted the importance of the recovery and recycling of raw materials. For instance, there is an objective on the recovery and recycling of the permanent magnets, because the supply of rare earths is very complex. But if you see in the bottom of the picture, the main bottleneck that we have to solve are the 4 pillars that are below indicated, which are more than 10 years currently in order to solve this when you want to launch a raw materials project and when you want to create investment, or you need investment to be attracted. First is the social license to operate, the social acceptance. This is something that is very different in many countries. Second, as I mentioned, endogenous resources, regional and local authorities. This is very important because without that, the rest is meaningless. You will never be able to place a raw materials project anywhere in Europe. At least what I know very well, which is Spain, impossible. Investments, as I was mentioning. Very important, missing deposit resources, which is all the tailings that are, and not all the geology to be detected, all the opportunities. So everything has to be linked to these investment mechanisms and understand that the richness that we have in raw materials and the important part in order to solve the supply or to avoid the supply chain rupture is to have these European innovation ecosystems connected to the industry to transform in situ the raw materials, which is the main Achilles, I don't know how to say in English, but it's the main weakness of the current European system. That even if we have raw materials, most of them are transformed outside of Europe. In Spain, we have the case of tungsten. The tungsten is extracted in Salamanca. Tomorrow we will have also here around the company of Saloro. Then the tungsten is moved to Australia. In Australia, it's transformed and then went sometimes to China, or sometimes it remains in Australia, to then be transformed into cutting tools in tungsten carbides. And then here in Spain, we have one of the top companies using this to transform metals. They are in Castilla y León too, which is, again, a paradox. So you extract the tungsten from Castilla y León, you go to Australia, to China, sometimes before to Russia, and then again it comes back to Castilla y León to be used in this company. So we are really generating CO2 in all the transport. So we are creating a big CO2 fingerprint, and we have a weakness, because if the chain is broken, then we cannot produce machine tools and we cannot produce these compounds in Spain. So we are working as cluster and as a strategic foundation in the region of Castilla y León, but at cluster in Spain and in Europe. We are really very active in creating this kind of European innovation ecosystems. For that reason, we are cooperating with different regions, and the last part of my presentation will be devoted also to show you some instruments that we are using, financial instruments, which are available for all of you. As an example, here we have the main tips that we are using, because we have a culture of innovation, we are using different instruments, we are creating or boosting everything of the investments through the innovation and technologies. And the important point is that we are creating, apologies because there is there is some problems with the translation from Mac to the PC, etc., but okay, maybe you can more or less understood some of the cryptic in that picture. But the idea, as you can see, is that we need to involve and engage in the same European innovation ecosystem the quadruple helix. That means companies, the innovation zone. So without universities, startups, innovators, it's impossible to launch. And all this, this is universal, but this must be applied to raw materials. Currently, it's not yet applied. We are working on that. We are creating clusters. We are creating associations. And we have in Europe, as you will see in the last part, we have the tools to engage and to make this possible, thanks to the funds of the European Commission and thanks to all of us. Very important, because people are forgetting hubs, business angel, public funds. That is, for instance, European Investment Bank, if at the end they accept to invest or to offer possibilities across the different parts of the value chain of raw materials, which is the important point. So raw materials is not only pure extraction, it's also sustainability, it's also exploration, etc., etc. We have also the creation of technological and industrial parks. This is something that we are doing in Castilla y León, we are doing in Spain, and our cluster is also replicating in other regions. I cannot forget, and I want to mention explicitly, the tool of widening and spreading excellence in Europe. Thanks to that, we have created hubs with Slovakia. We have Professor Juraj Jakob here from TUKE. We have created also platforms, as you are going to see, with Finland. We have created a network of these hubs in Europe, thanks to the I3 funds. So that's the way of creating all these synergies in Europe, because this is replicated per region, per locality where the endogenous resources are, or regions that are rich in raw materials like Andalusia or Castilla y León, but we need to be connected to the other innovation ecosystems in Europe. So for me, the answer to the Raw Materials Act is bringing together all these actors, because here we have the technological companies, the universities, etc., etc., and put them together specifically in cooperation across, diversified across Europe, but in cooperation where the industrial ecosystems, the valleys are. As I said, all this activity that I am sponsoring came from a long-term cooperation. We started with some European projects like Remix. We have many European projects that are creating this idea all together. This idea started in 2014 in a raw materials event like this one that we organized in Castilla y León. And that was the first of this in a cooperation between the government of Lapland and the government of Castilla y León, Governor Mika Ripi, Cristina Jokalainen, and myself. We started to work together to think how to create this alliance at the European level in different regions. At that time also, we invited GMB, I see Almudena, so we already started to deal and to discuss all these ideas with the main technological companies that were starting to put their technology and their know-how onto the raw materials value chain. No? The result is that we have created value across Europe, launching and participating in 4 smart specialization platform partnerships. One is the small and medium enterprise integration into the Industry 4.0, where we are leading and boosting the 4.0 integration in the mining value chain. So we coordinate different hubs from different regions. And these platforms, it's very important that we coordinate technologically, but with the governments. This is governmental activity. So we are creating these hubs, joining the policy, plus joining the technological activity. Of course, the mining industry, there is a mistake there because it's sustainable building, not mining, it's building. And there is advanced materials on batteries, where we coordinate the sustainable supply of raw materials for the batteries value chain. And because we are running on the time, as we have designed this smart specialization platform, we have created this kind of network of innovation ecosystems. And I wanted to put this plan here, and I did it in purpose, and it is not updated on purpose, because this is the slide that I presented in Finland 2 years ago of our plans to create together all this plan. That was a meta-hub European interregional on raw materials, the Innovation Valley in raw materials sustainable supply, strategic innovation valleys. And after 2 years, I can say, proud, that thanks to the cooperation with many of you, we really managed to fulfill some of these milestones, and we are still working on that. For instance, this year, thanks to the Finnish cooperation and thanks to the industrial cooperation in Spain, we won together the 2 permanent magnets hubs that are going to create a meta hub of permanent magnets across the full value chain of permanent magnets. The projects are RM Hub, coordinated by CLIC and GTK, and Permanet, coordinated by Técnicas Reunidas and the Iberian Sustainable Mining Cluster. And ICAMCyL Foundation is working in the Finnish project, and the Spanish project is working with the cluster. And myself, I will have the honor to coordinate, let's say, strategically and politically, the 2 hubs to really show to Europe that we have created this real cooperation between hubs and hubs across the full value chain of permanent magnets, from mining extraction up to investment and trading, and of course, engaging all the activities of sustainable technologies, recovery of permanent magnets, all the raw materials involved, new technologies for processing, all the value chain of the rare earths needed, how we process, how we recover, etc., etc. Also, during these days, we have here BATMAS project, which is an I3 project that we also ideated to make true the recyclability of batteries in a valley. This valley is coordinated from Milan, but is engaging also, again, all the full batteries value chain. We have created, very important, what I mentioned, this East European focus. There we have different objectives. We fulfill it. We have a twinning with Tuke University, and we have also created a collection of hubs which is coordinating from Greece about raw materials innovation ecosystems. Again, under the I3 scheme that I will use the last 8 minutes of my presentation to show you very quickly, and of course we can discuss later about this. And we, of course, have created this private investment platform. Tomorrow we will have a little meeting. It's not public, but this platform is meeting these days, and we are also discussing with the European Investment Bank possibilities to synergize public funds with private funds to launch very important raw materials project in the European Union, particularly in target regions. One of the target regions that we are discussing are the Balkans. We will have here also invited guests from the government of Croatia and some companies that are working with Serbia, and we will discuss some raw materials possibilities for investment there. Well, as I said, I will use the last 8 minutes before the coffee break to discuss about the new European innovation agenda. Something that I always like, because many of you know me since many years ago, I say, look, Santiago, how do you have all this in your mind? How are you getting funds from here and there and there? So the question is, of course, I invest a lot of time in reading what the European Commission is publishing. Most of us, we focus on our research, our technology, but we are not paying attention to all that. And I invest a lot of time being in Brussels and in reading everything which is published. And if you check that, it's not, I mean, everything is correlated. I mean, sometimes we think, no, maybe this DG is doing this, the other DG is doing that, etc., etc. Well, at the beginning I have this opinion, but later on I discovered that there is a very nice cooperation and correlation and really hard work of the European Commission functionaries to really make something meaningful for us. And sometimes the things really work, because the Spanish, usually we criticize always the different governments. It doesn't matter who is governing, we always like to criticize. But here it's not true. And if you invest time, you discover that there are a strategy. And I am proud that, that I have cooperated in the high-level groups to introduce the raw materials in this European Innovation Agenda and in the strategy of the regional innovation valleys and the interregional innovation ecosystems and investments. This is one instrument that DG Regio, together with ISMEA, has put on the table, on the desk for all of us. Currently, it's beginning to be known because I really like to sponsor this instrument because it's the first instrument, and I also congratulated in public many times to the European Commission, and I did from my heart. I mean, it's not because, again, most of you know me, I am really transparent and I always criticize what has to be criticized, so I don't have a problem to criticize. But in this case, I have only good words for the instrument. Why? It's the first instrument that really put on the desk money for innovation ecosystems, industrially driven. And that is seen because the first rule of the instrument is 70% of the budget must go to companies. Dot. This is for me an argument because I have been, I mean, I think I already have in my CV more than 90, 100 European projects. Always we do with universities, things. Okay, there are very good things on the pipeline that we have done together because here I have very nice and friends, professors from the university. But it's a reality, because I am also in this group of analyzing European results, it's a reality that a big percentage of the European projects never go to the industry. They remain on papers, they remain on studies, and it's our money, it's our tax-paying money. So it's very important, and the secret of making good use of the European funds is to have this kind of instruments. Because if you are industrially driven, Of course, I am not speaking, because this is recorded, so I don't want to mention, or I don't want to be an opponent, because I have been also excellent researcher, to the excellent research. This is another thing. This is low TRL. We need to invest in excellent science. This is mandatory for our lives and for our well-being to keep new ideas going on. But for the Raw Materials Act, it's a high TRL. We are here for the Raw Materials Act, for the raw materials. And the Raw Materials Act currently must be industrially driven. These funds, 70% go to the industry. And more important, in the evaluation scores, the most important in weight is the financial analysis of the project. And if the project is really going to create value in the region where it's going to be applied. So the only way to have a successful I3 is to engage industry and to really demonstrate that the industry that is going to get the funds will implement the project in the region and will create a value measurable, and you have to administrate in the template of the application a clear impact analysis, but not like the impact analysis that we are using to European projects. Really, a financial study, social study, if you want to be successful, the better you do this, the better will be your qualifications and your scores and your chances to get the funds. And this is very nice also, because this instrument is bottom-up. Bottom-up across different strands, different technology, different possibilities, different thematics, which are the green transition, so raw materials enter there, the digital transition, again, there is a lot of relationship, but for instance, in digital transition, you can do digitalization of the forest, of the agriculture, you can do, for instance, medicine, but of course you can do smart manufacturing, you can do grid technologies, anything that is providing value into your region. And smart manufacturing. The three strands, or the three pillars are related in a circle. And raw materials has been explicitly mentioned. I did a lot of strength, I really pushed for that. And of course, we have raw materials project currently awarded by this instrument. In particular, we are having a pilot with Atalaya Mining here in Andalusia and a big iron ore rare earths pilot in Extremadura. Just a little bit back, think that this instrument is not random, it's not by chance. It appears thanks to the creation of the European Innovation Ecosystems, the EIE, which is a policy that we are promoting in Europe to solve many problems. As I mentioned, we are applying to the raw materials. This is the idea of creating this innovation valley, which are boosted by DG Innovation and Research. So again, here, European Commission launched DG Innovation and Research activities from the innovation valleys that will be linked to the European innovation ecosystems, thanks to the I3 funds, so deep tech go to create these valleys, because remember that in the innovation ecosystems, you need to have all the value chain, from the deep tech, research, etc., up to the industry. So this is connected, and everything is governed thanks to the smart specialization strategies of the regions of Europe, with these partnerships and with all the governments. That means DG Regio. So this is the first time that DG Regio engages, well, it's not the first time, but this is a clear, good example that DG Regio engages with the European innovation ecosystems that Thierry Breton, DG Grow, launched, thanks to a policy, which are the smart specialization strategies, and thanks to an investment mechanism to promote industries and to promote industrial high TRL projects in the regions and in the communities to create value. I have just 30 seconds to be on time. Think that all these funds are going to be synergized with the idea of the Commissioner to have at least 100 regions, creating the value across the main workhorses of European Union to create these regional innovation valleys. As fresh news for you, we are creating, with all this architecture, we are of course working with Finland to create the innovation valleys in raw materials. Probably this year we will launch an application for that. Yeah? We are coordinating the different regional governments of Europe, of the main mining regions of all the European Union, which is very difficult, by the way, to manage this. And we are linking that with the hub that we get with i3 phones for connecting different European regions and launching new projects on raw materials. Thanks a lot. Thanks for your attention. Gracias por vuestra atención, en español. Looking forward to discuss with you. As I told you, we are launching new ideas for i3s, and if you have any question, we can have a couple of them, or you can catch me in the coffee break that we are going to have now. Thank you. Okay. Welcome back after this break. Okay. Okay, we are all. Now, again, thank you. Back from this coffee break. It is my pleasure now to open and introduce this roundtable that we have today. As I mentioned in my introduction, geopolitics and the global view and the global strategy is an essential element, a key factor in raw materials. And that's why we have composed a special international table to discuss this question. I have to excuse the presence of Ana de Palacio, our former Ministry of International and Exterior Relations. She had some health problems and she was not able to come in the last moment. But today with us, we have very important experts. We have Alexis Fauri. He's an investment expert. He's expert in energy, in raw materials. He is one of the main consultants that is working also in the European under mandate of the European Investment Bank in this study of the raw materials and investment profiles. He's also leading an important consulting company on energy and resources. He's working in the Middle East, Africa, etc., etc. And he has been also, or he's been part of our investment platform, the private investors that we are organizing from our cluster and from our private platform. He will be the moderator of the roundtable. I will be also up to help and facilitate and also to close. And also because I am very interested and happy to have them, I will also pose questions and put you in problems not expected in the table. With us, we have also to the Colonel José María Pardo de Santayana. He is the director of the Spanish Institute of Strategic Studies, and he has many positions in the army and in the strategy of Spain and in the OTAN and the NATO. So he has been also cooperating with us, also with Investors Club, since we started this activity. Thank you, Colonel, for being here with us. We have also Sebastián Contín. Sebastián is a geopolitics strategic. He's working as fellow in the University of Hong Kong and in National Chengchi University in Taipei. He's cooperating at different levels with the government of Spain, particularly when there are missions to China and when there are activities in the East. And he's also writing very important, quite frequently, very important papers on geopolitics and strategy for many important media. Thanks for making the efforts of being here. I have also, and I am honored that Sebastián is one of the chairs that we have as advisors in the cluster. So the cluster has a committee of high-level advisors. And Sebastián signed an agreement with us last year to also advise the cluster activity from the point of view of geopolitics. And we have also Max de Bruin. He's also a political analyst and research analyst in the Institute of Strategic Studies. And he's in the LCA Science Po University of Hong Kong also working. So both of them are, I think the word is sinologists, no? Or how do you?
Well, we are on our way for that. It's complicated, and also Alexi has spent some time there.
Yes.
It's a lifetime course.
So they are really big experts in the political understanding of China. Thus, all of you know the importance of raw materials and China, and we broke, we took here both of them to really make us to understand why this difference, how we have to work with China. And now I shut up and I give the floor immediately to Alexi, and the floor and the round table is yours.
Thank you very much, Santiago, for this kind introduction. So yeah, we've got three great panelists, between, I would say, the Spanish side of things and the China side. So East and West meets. And I have to make sure there is no war starting at the end of the talk. No, basically, China, since gunpowder discovery, I think has been always at the forefront of strategic raw materials. And they've been living in their part of the world for quite a while, I would say most of the recent history. And people discovered China in the last 25 years, first as a manufacturing hub. So we were providing resources to China for China to produce and sell back to our Western world and build up our convenient life in modern living. Today, China has also climbed the ladder of their own consumption pattern, and now they need resources for themselves. So that's where we are today in 2024. I remember being back from China in 2005. You couldn't find a Chinese teacher in Paris. They were all too booked because people were realizing that speaking Chinese was interesting. Today, you don't need really to speak Chinese anymore. They speak better English than all of us here. The one that do export or import raw materials. This is a shift of a paradigm, a very quick shift, I think, in modern historical times, because usually this kind of shift takes decades and sometimes centuries to happen. Today, it's a bloc facing the US, first of all, and I think there will be a debate around that, but also Europe and what is doing Europe to stay in between, to create their own policy. So on that, I think I'll give the floor to Sebastian, maybe to introduce a little bit this subject, and the floor is yours now.
Thank you, Alexi. Well, yes, actually, if we discuss the US-China rivalry and how this is affecting Europe, probably you would like to expand on that, I guess. Yeah, and I will maybe give a little bit, a few details about what's going on, because it's true, Alexi, that right now the US, with the so-called Inflation Reduction Act, the IRA, they are trying to balance, they are trying to find the way for counterbalancing China, especially with critical raw materials. And the focus is on the development of different, for the green and the energy and climate transitions. So the reality is that the fight for Europe is, with the US, you can always get some sort of agreement, as von der Leyen did with Biden when the IRA was enacted. But the problem for Europe and for all of you as business entrepreneurs and experts is the huge reliance of the European suppliers, the European market, on Chinese critical raw materials, right? So this is not only an economic issue. This critical raw materials thing is reshaping global power today. It's huge. It's not only huge today, probably the most relevant topic, I would say, is going to be even bigger in the following decades. So our future depends on these materials, especially for the green energy and tech transitions. All of us have to face great dependencies. China controls 60 to 90% depending on what's particular critical raw material. Mr. Lange was mentioning a few of them right before. But China controls 90% of the refining of those critical raw materials. You were mentioning how European or West was using China as a hub for manufacturing clothes, right? Do you remember? All of us wearing Chinese clothes. Today, they were climbing up the ladder, as you were mentioning, and it's a total different story. They are in the technology fight, and they are doing amazing. So they are becoming more and more relevant. And I wanted to quote, to remember, Deng Xiaoping's words more than 30, 40 years ago, saying, the Middle East has oil, China has rare earths. So they knew very well already 40, 50 years ago that this was relevant. They had the vision for understanding that this was going to be big and very important. Global demand for critical raw materials today is skyrocketing. Santiago was referring to this, also Martin Lange. And the issue is that this China dominance makes them able to, whenever they feel like, block exports, flood the market, and obviously this allows you to control the price and also to manage the stockpiling, something that this cluster is very focused on. So in the end, if you can restrict supply, control the prices, you can also apply political pressure, right? And become geopolitically even more relevant than you are today. So what was going on? It is with the pandemic when all the countries, especially European, realized, oh, we have really strong vulnerabilities. And actually those vulnerabilities are relying on just one supplier for strategic assets, which was China. Then after the pandemic, with the war in Ukraine, when the war in Ukraine started, and probably you can expand on this a little bit more, Colonel, yes, this is a total different story because it's changing the pattern of how global power is managed today. But after the pandemic, the war in Ukraine, all the countries try to secure the access to strategic resources, and this becomes a race. In what position Europe is. So this is why the Critical Raw Materials Act was probably the fastest done in the last years, because the Commission, thanks essentially to your opinions, experts pushing, underlining how this can be relevant for everybody, for everything we do. We can't only rely on one supplier. I mean, China knows and China understands. If you follow the political narrative, maybe they say something, but that obviously has or is directed to domestic audiences. But the reality behind is that they know very well that this is unsustainable for Europe. Okay,
Colonel, how do you see the policy-making shift to answer to that kind of new paradigm with China taking the lead?
Well, I would put the emphasis that from our perspective, from the Western perspective, everything changed in the year 2017. Until this year, there was an optimism in the West. And since the end of the Cold War, raw materials were not a strategic issue of relevance. But from our perspective. But from the perspective of Russia and China, things are very different. Because they signed a strategic partnership in the year 1996. Most people forget this. This partnership is old, and this partnership was signed to change world order. Then we were living in a unipolar, hegemonic US world order, and they were working together to build a multipolar world order, where we are today. And we are in front, if we look at from the perspective of the West, we are in front of two countries that dominate the field of raw materials. China, because it's the main producer and refiner of this, and Russia because it is the country that has more natural resources in the planet. Both together makes the issue even more serious. If China initially started to put a state emphasis on raw materials to reduce vulnerabilities because they were receiving all this from outside, US was dominating all the oceans and dominating the traffic. So if the US wanted to stop the trade of China, they could do this, so they started to put the emphasis to reduce vulnerabilities, which is easy to understand. But through time, when China was developing and feeling it was strong enough, it started to use this to gain power and influence in the world. And this is where we are now. Now, through raw materials, they have power and influence, and they can use this as a geopolitical tool. In the case of Russia, it was not like this. They were basically working in this field because of economics. And when we think in Russia, we think, well, Russia is an energy superpower. It is. It is the main exporter. It is a weapon exporter, but it is a minerals power as well. So we see we are in front of very serious rivals. But at the same time, since they signed this partnership, both Russia and China were having a strategy for the region we call now the Global South. Why? Because the US is dominating world economy through the dollar, and the US, because of its position and its tradition, had a great influence in all the regions of the world. So they were working together to reduce the influence of the West in these regions and to fight the possibility of the US to use sanctions. In fact, US has abused of sanctions, and now sanctions are weaker because of this abuse. So in the policy, both Russia and China have used to fight for the influence of the Global South. Raw materials, as we know, play a very important role. So now they have the advantage that they have been working on this line for a very long time, and the West was in a very optimistic mood, and now we really need to change mentality and work in this field, because raw materials is becoming a battlefield for power in the world.
Exactly. And talking about battlefield, now we move to Africa with Max, because as much as China and Russia cooperate historically, first on the ideology, then on resources partnership, following this partnership, they also built up this huge crude oil pipeline, gas pipeline, exports through Siberia to China. But in Africa, it's a bit of a different story, because Russia and China has got different angles to actually compete in a way in Africa with the colonial powers. So Max, what is going on in Africa?
I don't think I'd really have to elaborate on the importance of Africa, right? I mean, its reserves in terms of magnesium, in terms of coltan, in terms of lithium, it already makes it a key player in the global energy transition, right? So there's no much need to elaborate on why it is that important. I think everybody in this room is pretty sure of its importance. But I would like to just start my my intervention just by mentioning that there's a need for European countries, and especially its companies, to adapt the strategy of investing in critical raw materials and locating those resources and extracting them, right? This is because there's one key variable that's changed in the last, perhaps in the last decade, but especially in the last few years, which is the arrival of new actors, right? You have a lot of non-Western actors. China has stepped up the geopolitical game, it's raised the geopolitical stake. Russia is also a country that's taken a particularly antagonistic role when it comes to, just put it this way, to spoiling Western interests in the region, of course. But apart from this very traditional, two powers, right, Russia and China, there's also a lot of non-Western actors that are very important in the region as well. These are Saudi Arabia, the UAE, Israel, Turkey, India, right? So this is a very condensed market where there's a lot of actors right now. And there's, apart from this, the fact that there's a lot of powers that are struggling to, that are attempting to climb up the value chain and trying to make offers, investment offers, you would try to, a lot of experts would perhaps like see it as some kind of new scramble for Africa, right? Like where these African countries are being exploited by other global powers. And this is actually quite far from the truth. In fact, if we look at the way African countries have reacted to the Ukraine war, it is already displayed quite surprisingly, much to the surprise of a lot of Western analysts, it showed a certain degree of disconnection, diplomatic disconnection from the Western narrative, right? So what we're seeing now is a lot of African countries, they're deciding to take matters into their own hands, which they're trying to do what the global North has always done, which is to make decisions and to look at the pros and the cons and make decisions according to what's best for them, what's convenient for them, right? And Africa, again, it's really no different. And in this kind of context, right, the fact that you have a lot of new actors and you have states in Africa that are basically receiving the delegations of the whole world who don't feel like they need to take a side and who just wants to diversify their partnerships. My main recommendation, what I hope that the audience takes away from this would be that there needs to be you have to make your investment offers more competitive, right? I mean, what are all of these countries in Africa looking for? Some of them have more ideological preferences, others don't. Some countries are indeed trying to basically divert away from the West. This is especially in the case of West Africa, where there's been a couple of military coups. They're driving out Western presence, especially French presence. But this is not really the case of the majority of African countries. They're just trying to use this position of to leverage their situation right now, and to take advantage of the fact that there's a multipolar world and they do not have to take sides. So they're just trying to get the highest bidder, right? So my advice would be to be more competitive in your offers. Look at what your competitors are offering, be it Turkey, be it India, be it other countries. And this is not just applying to Africa, this is also to any other resource-rich country, right? So you might have to look at the percentage of ownership that you're having if you're engaging in a joint venture, right? Whether the degree of technological transfer or training that you're offering to the local population. So that would be the key takeaway that I hope the audience gets. Europe overall has to adapt their strategy to resource acquisition and be more competitive given the situation that I've just described, yeah.
Thank you, Max, for that. Maybe we'll dive a little bit more on the specifics on the application past the competition policymaking and what's the implication for EU strategic supply on the military and defense system, Colonel, because as much criticality and strategic, trade is good, but
Yes.
you need to ensure that your ecosystem on the defense side is protecting your interests.
Yes, to understand the problem in Europe, we should look first what's happening in the war in Ukraine. Many people thought before the war and at the beginning that it was just a question of time that Russian economy would collapse. And this was the Western strategy. Let time play in favor of the West, in favor of Ukraine, and let the Russian economy collapse. It hasn't happened. Why it hasn't happened? And why we did not understand what would happen? Because raw materials play a key role in this. Only because Russia is so abundant in raw materials, they could transform its military industry in a very short period of time in 3 shifts and produce more weapons, Russia alone than all the West together. Without raw materials at home, Russia could not have done this because it's very expensive, because it takes time. So the advantage in the field of raw materials, critical or not, is really what has permitted Russia to adapt so quickly and to have now an economy which is growing more than the Western economy and more than the US economy. So what happens with Europe? Exactly the opposite. If we would be in a crisis and we need to produce more weapons and ammunition and we would like to work in 3 shifts, we have a problem. Because we could not react so quickly so that we can receive in Europe all the raw materials we need. And in any case, if this happens, the price of raw materials would skyrocket. So we really need to be conscious that if we are in a crisis, and if in the crisis is China present, we'll have a problem. Because we will not get all the raw materials we need to produce in our own industry the military means we need.
Maybe you want to bounce back on that because what's, I mean, Europe is facing honestly complex, realities, deep needs on strategic raw material supply, defense, protecting, basic trade, energy transition, and then all the environment, politics, I would say, surrounding it. And it's a bit sometimes of a, big dilemma to handle through policy making. And so they've been enacted, like, the CRMA and other legislation in order to foster, investments, research, kind of control on the basics of the supply chain. But at the same time, they are facing a race and a speed, to the market that other markets like China or the US, they have in their own toolkits, much quicker, much more powerful, like the IRA you mentioned in the US. acts and policies that usually move faster and basically race against Europe. So how do you see Europe kind of addressing to the pace of legislation and lawmaking? And,
yeah. Well, Alexi, what you are describing now and what the Colonel was describing right before is, if we can put it, if we can concentrate, or if we can frame it in a way, is both of you are talking about the same thing. It's a change of paradigm today that we have all to consider that economy today is at the service of security. Security is more relevant today than economy. The economy is at the service of security. This is a huge change of paradigm today, nowadays. It's happening in Russia. We have discovered it with the war in Ukraine, with Russian access to all those amazing resources. About how also the European Union is reacting. No need here to explain why Europe reacts slow, because all of us know Europe is not a Westphalian state, it's a supranational organization. So putting together 27 opinions is very complicated. It's very hard. And now we are talking about security. So this is actually a step Europe has to decide to make or not to make, is, do we, states, give power to our common institutions in order to become geopolitical? You might remember Ursula von der Leyen starting her 2019 speech when presenting her agenda for the following 5 years, saying, we are the geopolitical commission. Today, 2024, she's now conforming her second team, and she didn't succeed. She didn't succeed. This is the reality. Europe is not a geopolitical power today, and that's a fact. And in 5 years, the commission that was in the work for the last 5 years was unable, actually, it's something I'm researching for the last 2 years, because it's very interesting. Why was not only not possible to fulfill this goal, but how was possible that Europe became weaker? That's the reality today for Europe. And it's very hard because today, Max was describing what's going on, the fight in Africa, right? You were saying it's not only Africa, of course it's not. You see how ASEAN countries, they are using what they call the bamboo diplomacy. Is flexible and strong. They are playing both sides, right? We are not with the States, we are not with China, we are with both. With this one we do security, with this one we do economy. And they have discovered that being in defense is possible and useful, especially Vietnam, Thailand, Indonesia. So is Europe going to be able to become the middle power, let's say, the balancer between the US and China? Because the great fight we are witnessing today, and is going to increase and go further, is the US-China rivalry. What role do we want Europe to play there? If we want Europe to play a role, right? So this is going to define everything. And part of the game is, of course, what's happening with the critical raw materials.
Max, on this one, Europe still being a dominion of the US, or having its own policies and being able to enforce and kind of bounce back as the third power? What's your view on what's going on within the the stream of the energy transition, the security needs, the new geopolitical factor, and saying Europe potentially becoming geopolitic rather than, again, like a supranational institution that just kind of follows and provide trade security, but not like actual security in geopolitical terms? How do you see that kind of place?
So I think one of the main issues here is that we have different contradictory priorities, right? I mean, the EU has been passing a couple of landmark pieces of legislation. One of them is the reason why we're here today. But the thing is, like, these different pieces of legislation, they're pointing towards different priorities, and what is, I believe that one of the things that is preventing us from being like a 100% more unified and more cohesive and more coherent power in the international scene is the fact that we have to meddle between, we have to juggle all these priorities, right? So just want to bring your attention to Dragi's report. I read it, so you don't have to. I still think that you should read it, but it's a very long report. So if you look at page 45, Draghi talks about the automobile industry in order to give an example of how this is something that started with a a bit of a green economy undertone, but it was never accompanied by it was never accompanied or supported with a proper industrial policy, right? And this is something that we can see now, and in a very serious, there's a very serious example of this, which is the fact that a lot of European car brands are now lobbying the EU so that they can postpone the 2035 date to phase out internal combustion engine cars, right? This is because European car brands are already making it clear that it's very difficult for them to reach this target, this green target, which was set initially by the Net Zero Industry Act. And they started pointing at the fact that they didn't, that their supply chains were not resilient, that they needed the minerals, they didn't have the critical raw materials to fulfill this. So just right after that, we had the Critical Raw Materials Act, which is the reason why we're here today, right? This is definitely a very sensitive piece of legislation because it's trying to counter China's practical dominance of vertical value chains when it comes to the extraction, not that much extraction, but specifically the refinement, right? Around 90% of the refinement of most of these minerals takes place in northeastern and northwestern China, right? And another concern can also be that in northwestern China, there's also been alleged human rights abuses, so that also puts us in a difficult situation as a geopolitical actor, right? But the problem is these two pieces of legislation are putting forward two priorities, right? Like first it was the green energy, right? And now it seems like it's geopolitics, right? I mean, I think Sebastian has already pointed this out in some of his writings that the Critical Raw Materials Act is now making, even though it definitely makes. It's not that I want to contradict necessarily what Martin Lange was saying, but I can tell that sustainability is kind of taking a back seat, right? It looks like geopolitics is really like on the table, is really at the forefront of this piece of legislation. But this is contradicting the previous priorities, right? So like how do you breach this? Like there's now a dilemma between the geopolitical realities and your sectorial perspectives, the fact that now in order to gain investment projects in Africa or in other countries, you might have to compromise on some of your sustainability rules, which are self-imposed, right? So this is also something that Mr. Cuesta was also talking about, which is the fact that if we also impose this kind of rules on ourselves, we're also going to be less competitive, right? So in this case, it seemed like the EU is presumed to be the enabler of all of you and to act as some kind of business diplomacy vehicle, right? But as long as these priorities are not really are not consolidated and reconciled, it's going to be very hard for Europe to act in a cohesive and strategically, like in a more cohesive and perhaps in a more effective way in the international scene.
Okay, so should I say that basically, if you're in business, you should prioritize basically your focus on the trade side, on the defense supply, because now we are getting more geopolitics than kind of sustainable, as in objectives. Mm-hmm. And are you more likely, you think, to have the attention of the EU if you're more in the strategic raw material in a defense way rather than in a green way?
It's a very good question. I would say that it depends on, you're always going to have two indicators, right? You're going to have the geopolitical risk and your own traditional business risk. What are the fixed costs? Sometimes both of these factors are going to align. For example, we take the example of Niger in West Africa. France is in a very difficult situation there, but in fact, like they were also, Orano, which is the main mining company there, was already mentioning that yes, they are having a lot of geopolitical issues there, but at the same time, their fixed costs have been increasing since around 2013 because of security issues. So sometimes you need to find a balance between the two, right? I would say that it doesn't necessarily mean that you need to prioritize just geopolitics or the other. I would just to quote again Deng Xiaoping. I think we're all sinologists and pretty much all sinologists in this panel, so we're very interested. I would follow what is one of his most famous sentences, which is in Chinese, 莫之石头过河, which is to cross the river by touching the stones, which is to not provoke a retaliation from any of the sides and to try it out and see how it goes, right? I would say that right now, yes, if you're willing to go for the full security, on a very security side, like you're going to have the support of the EU, that's for sure. But at the same time, if you go for a de-risking strategy, if you're part of the EU's de-risking strategy in a very ambitious and aggressive way, it's also very likely that there will be retaliation from China's side. And right now, they still control around 85 to 90% of the refining, right? So I would recommend just not that you go more for geopolitical considerations or business considerations. I think both need to be taken into account. And I think it's just a matter of, in fact, I wouldn't say that you should be considering more one or the other. My key recommendation would just be to integrate geopolitical risks into your thinking, but not necessarily to just consider that right now. We're not trying to make you go from one side to the other. I think you should keep your own business risk calculations, but you should take into account the geopolitical risks. Yeah.
Yeah, Sébastien. I was curious to see like how the integrated part of China, like they integrate a bit like the US, but even more vertical. Norinco and the state-owned the SOEs in China, kind of they integrate first the defense priority, and then they kind of cater for the economic development, right? But it's all state-driven with always the defense. Is it changing now, or are they driving the CRM, SRM, demand in China or control in China through their defense apparatus, or do they use SOE in a more kind of economic, again, do they kind of start to split a little bit in China the economic ambition they have versus the defense needs that they still have to, to supply and to be in phase with the historic of the Communist Party in China? Like, do you see something changing in China there?
Well, you are rightly pointing out to something that is key in the relationship of China with all the other countries all over the world, is they play with another tempo. They don't have elections, our hurries, so they can plan, and they have all these vertical supply chains that allow them to do it. And even though, right, like today, they have economic problems, they have this long-term vision, and obviously they want to solve all those problems, especially because they shouldn't become bigger, but we are always in a hurry in the West, and they are always taking it slow, stepping in the stones that Max was mentioning. And there is, again, right now we look like sinologists, really, because Deng Xiaoping was also saying, keep a low profile, right? Keep a low profile. And they were doing until...
He was short.
Yeah. They were doing well until it's so obvious that they became a giant. So the thing is, how are they able to, even though they are going through economic issues, able to leverage, as you were mentioning, all this supply chain power on different industries, critical raw materials? So that's the key, right? You both said that word before. It's dilemma. Europe has a dilemma. So why our leaders don't solve those dilemmas, right? Why don't they decide? This is, you were saying now, climate, geopolitics, do we make a mix? What's more relevant? So that's probably the main critic you were saying in Draghi's report is he's saying either you do climate or you do geopolitics. But if you have to be more competitive, and this is the key, what are you going to do? This is the message to the new commission, right? It's actually a report that all of us know people in Brussels, to what extent was not commanded for saying that those measures that are very hard to put into motion have to be taken and blame someone else, which is Draghi, right? So this is probably going to happen, but now they don't have a second chance. They just have to do it. China is supposed to have, is allegedly having 15 years 15 years lead over all the rest in terms of critical raw materials industry. So this doesn't mean that tomorrow, because we have this now fantastic Critical Raw Materials Act, tomorrow we are just catching up with China. No. They are probably going to increase those 15 years to 16 or 17, and maybe once the European Commission is putting into motion all those measures, some of them you were mentioning, like the valleys, the industrial valleys, the stockpiling. What are they waiting for? You have the law, it's enacted, it's already operating. Move forward, do something, especially with critical raw materials, with critical resources, with strategic assets, because we know that we can't rely only on one supplier.
Colonel, do you see one of the factors of this dilemma still being a dilemma as being some kind of foreign influence within the European ecosystem, right? We know that Brussels is like the biggest nest of spies in the world.
Well, no, the reality is...
How do they play?
The reality is that from a security perspective, United States and Europe play in the same area. So, and the reality is that this rivalry between great power is there and probably will grow. So we have to think about how to manage this problem in a geopolitical environment where tensions will grow. How much time this will grow, I don't know. But what is very clear in all strategic documents is that we are living a very complex decade. Kevin Root wrote about this problem saying, this is the decade we will live dangerously. And then in the US national strategy, they say, we are facing a decisive decade. So we cannot wait for next 20 years. We have to solve the problem now. We are in a hurry because everything is going very slowly, and we should be ready for the case from a security perspective that we have a serious crisis, which is probable, highly probable. In the case of serious, what do we do to react to this? And if we are in a crisis, we need a stockpile to gain time until we know exactly what to do. So this would provide us time. We need to, of course, to diversify all the supply chains. We need to secure them, but we need to reinforce our own sector. So we cannot maintain this amazing external dependency. And this is not something we have to start to plan today, so it is solved in 15, 20, 30 years. We should solve this in this decade. If not, we have a security, not a security dilemma, we have a security problem.
Okay, but we would have to choose side all the time, right?
We have chosen sides. We are on the side of US. Yeah. And the most thing we could do, which is what I would propose, is play the role of moderators. But we know very well where we are. But we could and we should moderate first to reduce these tensions, and then be ready for the possibility of a crisis. And we always have to plan for the most dangerous hypothesis. If we have a crisis, the more serious the crisis are, the bigger the problem will be to access to raw materials. Because if we have a problem with China, they will use the position to create us a problem. So in the case of the most dangerous hypothesis, we have to be prepared for this. And this is stockpiles, reducing dependency, having more ambitious strategies and more ambitious policies.
Okay, thank you very much. Santi, you want to take a question?
Yep. Thanks. Can you hear me? Yes. Well, I like it a lot, your intervention, Max. First, because he launched you some homework. Who in the room has read the Draghi's report? Okay, good. 2, 3. Okay, myself. So you see, only remember my speech. Please read what the European Commission is providing, because there are a lot of clues, a lot of things. Second, and now after this, let's say funny remark. European Commission is really, I mean, because I like it a lot how you introduced this Africa relationship, no? And if you check what the European Commission is trying to do, particularly DG GROW, they have launched a particular mission on this, how to say, this international relationship to fulfill the Raw Materials Act with some countries in Africa. But in my humble opinion, our mission is totally naive, because China and Russia are already positioned in Africa. So now the question goes to Max, but also to you, to anyone on the table. All of you are positioned in Africa and studying. How do you think the European Commission has really can focus or can arrange or can make the plan to really make possible this presence of Europe and agreements in Europe with the African countries to, for instance, secure a supply, do a practical stockpiling, secure the investments of Europe into Africa? how this is going to work, because the way that we are doing is now we have done a mission, we have an agreement with the government, blah, blah, blah. Yeah, but in reality, this is not the real world, no?
I have maybe one piece of experience in Africa, and I'll use the Mozambique. I mean, Mozambique is critical for gas, right? It's a huge gas supply for the next 50 years. Basically, you always have this EU representative mission, as you say, right? It's not really an embassy, it's, you know. Exactly. But, you know, in Africa, over the last 5 years, you know, the German government has been providing 3 times the amount of aid and, you know, basically monetary policy into Africa, more than the French. And traditionally, the French and the Brits were, you know, cutting Africa into. The Germans are acting alone with big means. And you see that, and you see basically in this country, particularly strategic, you know, on the regional map of Africa, Mozambique, you see all entrepreneurs, all investors are coming to the German embassy. No one comes to the EU rep, you know. So they are coordinators, they are doing the in-between, the mediator, as you say, like what, like Switzerland? I live in Switzerland, it's an 8 million people country. And so basically the EU wants to take the role of a country as big as Switzerland, but you know, which Switzerland has been doing this role forever, and they still host this peace conference and this mediation on a lot of topics. And so Europe wants to be a bigger Switzerland in Africa. But that's what the reality is going on today. They have no clue. The Germans are doing their own way, like a neo-colonial way of doing things, with more partnership, more inclusion. They deploy money straight on. They don't wait for 10 years to kind of say, all right, we allocated you, you know, 10 or $100 million for this project. And the EU still has a rep, but it's a kind of a vacuum, and I don't want to blame the EU for that. It's a reality that is going on in a country where I've done some work in
the raw materials, they are starting to do the same approach. And what could be also the I don't know, any suggestion, anything that we can elevate to DG Grow to really make this better? No?
Well, I think the good news is that not everything is lost. And that's why there are possibilities of improving the current situation. And you were mentioning, I don't remember if you or sorry, the person from the commission, Mr. Lange. So you were mentioning the minerals security partnership. So something that is going on right now there is very interesting, because we were discussing a few days ago this about what's going on for the integration of Turkey inside this. I think has been going on since 2023. And there is the US, there are the Western powers and India. And right now, Turkey is about to join the group. So the reasons why is what gives hope, because the Turkish are saying, oh, they want to play what I was referring before as bamboo diplomacy. We play with all the actors. We don't care, we don't support you or you. We just want to get the best for our country. And this means that I don't ally with you, and I don't ally with you. And unfortunately, as the colonel was saying, Europe has already decided. I mean, the leaders have decided for us without asking, because we are still democracies, right? So why do we have to align with the White House? Why can't we be in the middle? I am not saying that we have to align with Beijing, obviously, but let's balance this. So this mineral security partnership is probably a way that is going to show us a potential path, right? Because now Turkey is saying, no, I still want to refine in China because I don't have the facilities, but you, through this partnership, are going to provide me the funds that are going to allow me to build all the different infrastructures for me to do it in the future. So China is scared, probably very scared, because they say, okay, let's do business now, but these guys are going to free ride and are going to do whatever they want. So this is an example of how partnerships can play a role, and still the fact, and this you know much better, than the resources are underneath. And many days we are reading, oh, the biggest of lithium in Europe found, the biggest of graphite somewhere else. So almost every week we are reading that the biggest of something has been discovered, because now also the systems are improved, there is more interest, and more there will be opportunities, because the market right now is obviously occupied, especially by China, but this doesn't mean it has to be forever like that. as long as you offer better agreements, better conditions. Also, if I may say, if Europe forgets about this kind of exceptionalism, like you have to go, no, we do business but with values. But who is caring about values around the world? You do business or you don't do business. But why do you have to try to improve their political systems? They never did. We know by experience they never did. We never changed anything. Why do we have to always say, no, they have to adhere to democratic principles and blah, blah. You do business, you become geopolitical, or you don't. There is no middle way there.
If I could, the problem is not only that they are not paying attention to us when we speak about values. The fact is that China and Russia is using this against the West. And if you read the concept of foreign policy written by Russia 1 year ago, there they have a narrative where they are trying to present the West really as a new colonial power, and they're using exactly this. So they are using this against us. And I would like to say another thing is, because we have a very serious war in the East, all the attention of the European Union in terms of security is going to the East. We, Spanish, in Spain, we are putting a lot of emphasis, both in the European Union and in NATO, saying we should pay attention to the South as well. But now it is impossible. All the attention is going to the... So if we have a very long war in Ukraine, sooner or later, the Russians, if they cannot resist this high pressure, they will work destabilizing in Africa, because the Russians have arrived in Africa to stay. They know that NATO and the United States are by far more powerful than Russia. And there are 3 countries that use this destabilizing strategy systematically, because they always fight against a superior power. This is Pakistan. We have the case of Afghanistan. Afghanistan is destabilized forever, because Pakistan will never be a stable Afghanistan related to India. We have Iran. Iran is fighting against a lot of different powers by far stronger. So for the last 20 years, Iran is destabilizing the region, the only way they think they can survive. Russia has done the same thing. For example, in Ukraine, they thought that by destabilizing Ukraine, they could avoid Ukraine to enter into the NATO. So if they arrive to a point where they see they are too weak, they cannot fight NATO and the United States, the danger that they start destabilizing the South to force the European Union to pay attention to the South and not to the East exists as something rational to think about this.
Good point.
Max, you want to say something?
Just very good remarks.
Yeah.
Yeah, sure. Yeah, no, I was just going to say that I think another takeaway as well is, and I think this is a very interesting case that I will probably elaborate on perhaps tomorrow, but in general, I wouldn't necessarily think that there's that much of a problem with engaging with Africa. There's only few countries that have really taken very, anti-Western stances, but the majority, they're basically adopting the very same mentality that we're seeing around the world, which is like you don't really have enemies, but you also don't have friends, and you can just you can be multi-aligned as long as you balance out a little bit your commitments with different parts of the world, right? So I think the winners of the ones who will navigate this trend the best are the ones who understand that we need to abandon this like colonial mentality, not just the West, but other countries around the world that also had some colonial heritage, right? We need to abandon this idea that just because, these countries were, our colonies, they will only trade with us. But this goes both ways, because the best example is currently what's happening in West Africa. Yeah, France was very smart to realize that the same reason why West African countries are basically trying to drive away France is also the same reason why Central Asian countries are also trying to drive Russia away, and they're also trying to diversify their partners. And Martin Lange was already mentioning that the EU has a lot of presence in Central Asia. Uzbekistan and Kazakhstan, they both account for around 40 or even 50% in terms of rare earths, in terms of specific deposits of certain key raw materials. So I think Central Asia is a very interesting place to look at. And I think another example is Mongolia as well. I mean, Mongolia is a country that nobody would expect to be dealing with the West so openly, because they're basically, just to put it this way, they're sandwiched by China and Russia, right? But the thing is that they're actually engaging with France. They're building a new mine with Orano. And I think this is, I think that's the key, right? Is to understand that, yeah, just because you have a difficult story with this specific part of the world, you know, yes, we have a specific difficult story with a part of the world, but other countries do too with their immediate neighbors. So the trick would be perhaps to go to other countries that are seeking to, you know, diversify their partners, right? So, yeah.
Good point. I think we can close, Alexei.
We can close it very nicely. Thank you very much for this intervention. We can keep talking even forever. We know that. But no, I mean, good point to take away is that we have to act quick. We need to push as much as we can, and we are doing that, Santiago, together with trying to clarify at the EIB level some proper investment package and investment decision to kind of foster basically some part of the EU money into the whole value chain of the SRMs, rather than, as we say, saying that climate should prevail on top of foreign policy or security or something. It's like, we have no time to think much about it. They are kind of realizing it, I think, in Brussels, and then we are here to help and to kind of show them that, you know, the clock is even ticking faster and time is compressing. And so, yeah, all these points make the valid legitimation of our work, and then of your work in trying to, you know, develop your project as fast as possible.
Very good. Any question in the audience? Please.
There are many.
Many. That's good.
Thank you. Hello. Thank you for the panel. It was very interesting. My name is Manuel Barbera. I work for the Australian Trade and Investment Commission. Australia has some of the world's largest reserves of lithium, cobalt, and rare earth, and it's a Western country with very high ESG standards around mining and other things. What do you think? It's a question to the whole panel about the role of Australia in the critical minerals, and particularly for the EU.
Well, Australia belongs to the Minerals Security Partnership, as far as I remember. They are usually joining any Western initiative related to security. So obviously, and you have also the AUKUS. Obviously, they are on one side, and on that side, I think there are many opportunities, because the distance here, you know that the West and the East are concepts that are not truly geographical. So Australia is considered a Western ally fully, and the reality is that can only grow right now, because if you consider the span of the last decades, they are getting more and more involved into Western initiatives, especially because of the American push rather than the European. Yeah, for Europe, you know, it's strange because we have lived in Asia, and there you realize how it's possible that there is this lack of understanding about these lands, and there is not real expertise. You were mentioning about the Chinese, the language. It's very surprising and very sad, and I've been told this also by many officials in the European Commission. But this is not Australia's problem, because you have think tanks, universities so really focused on what's going on in the South China Sea, in the Indo-Pacific. And there you have the knowledge, and obviously this depends also on your leaders, but they have the capability or the resources for making right decisions. So to sum up, I think that relationship can only grow, and I think it will be good for everybody there.
If I might complete and also answer you, Australia is considered one of the easy ones to deal with. So they are in. This is one of the easy thing, no. Second, Australia and Canada has been involved in the particular strategy of the European Commission of the raw materials Act from the beginning. There is also a synergy with Japan. From the very beginning, many of the technological value chain were analyzed and we invited in different events in Brussels together Japan, Australia and Canada, so they were more or less the first. Then the European Commission put the eye on the Latin America, so the idea was to create a solid partnership, particularly with Chile, Argentina and Peru. That was the main driver. And also the OECD, we were working together, and we have the pleasure, I see here colleagues from Finland, we were invited and we engaged together the mining regions and cities activities that we have launched in Europe. We went to Australia to learn from you, because in Australia, really the concept of mining ecosystem is really very deep established. And the idea is that we are trying to learn lessons, and part of this partnership is to learn lessons from South America, Canada, which is some kind of our lighthouse, and Australia, which is the other one. So we are taking Australia and Canada as lighthouses for us, and also, of course, as part of the important pieces for this hypothetical either stockpiling, because again, in Europe we are in debate about this, because there are different countries, there are different opinions. We don't have more time to discuss about this, but it's crucial for the defense to have this stockpiling. This is my humble opinion, and also not only from the defense, from the industry. United States is doing, Japan is doing, so Australia is here to play one of these roles, because in the geopolitical and in the geography, as Sebastian was saying, is in the middle of everything. So I think this is very important, because in order to transport the minerals, we don't have time also to enter into the transportation logistics, where to cut things, because there are possible blockages of the transportation. And for that, a strategy ongoing. I mean, I am speaking more because the experts on geopolitics and strategy are them, But from the point of view of physical logic, because I'm a physicist, if you want to transport with a minimum effort from here and there, you need to have allies at every part of the world, Exactly.
Yeah. So anybody else?
Other questions?
Oh, we are told that there is no time. Okay. Last question, right, Alicia?
Okay. Hello, this is Kumar from Nanopower. We are producing nanoparticle silicons. So I think this is a great opportunity. We are here to hear about your advice about how we can do huge change in Europe, especially what is going on in Russia and China. It's a very thing we have to take very seriously. So I just want to go 2 steps back. Already you mentioned about the discussions. China we heard about 25 years ago. Now China is leading a lot of production of different minerals, raw materials. But if you go back several years, Europe was leading, especially Spain was leading. You see, we can't forget this. But somewhere, now we are not leading, China is leading. Why? Because they see our steps, our movements, and they try to think 2 steps forward. That's the reason they are leading. So now we have a lot of action, we want to take it here. But my question to you, the panel, you are the expert, is it some way we can think, when we compare China and Russia, we can think at least 2 steps forward in this raw material production side? Because this is important. Why? We have to be more aggressive. We have to have a long-term and short-term plans. And it must be things at least not protecting, how we can increasing raw material. We have to think what we have to do after 10 years. How we can speed up here. This is my question.
Yeah, thank you very much for your question. I would still say that there's 2 different drivers that can like enhance or like accelerate this kind of strategy, right? Like now it seems like we're really trying to forget, what Europe and the US have always been good at, which is having an organic environment and having a venture capital environment, so that so that it goes more organically, more naturally, right? Why has China been so good at this? Is because, well, they set it up in 2013. They already set up this this plan, like Made in China 2025, right? This is a very good example of industrial policy, and China is very good at that. Of course, like they don't have the election cycle, they don't have to think they don't have to think short term. They're not constrained by this kind of milestones that we always have in the West, like elections and everything, right? So like they can think long term, and they also have. Because of they used to have follow a more, you know, like a state planned economy before. They still have there's some good remnants of that. I mean, China's still very good at economic planning. They still have, you know, 5-year plans. They just announced one this summer. So even if they're you know, pretty much developed country, it's still difficult to discuss. There's a lot of contingent points there, but despite their economic development, they're still very good at that, right? I mean, this is something that would be quite difficult for Europe to do. I think Europe, we need to have an industrial strategy, but I still think we need to still focus on what we've always done best, which is organic growth and through facilitating not only venture capital, but entrepreneurship and innovation, right? Like, yes, we do need more support because this is what our competitors are doing, but I still think what is going to differentiate us from them is also having a more organic approach. Because the thing is, yes, it looks fantastic on paper, you know, like, okay, China, you know, they have all of these targets of like the market share they want to achieve around the world. Okay, we want to like dominate the car industry by this %. They want to like refine, you know, by 90%. And yeah, they're achieving all of this, but this is coming at a very high cost, which is their own overcapacity issue, which actually, in my opinion, hurts China more than it hurts the rest of the world. They have really big price wars in China. People work very long hours, and most companies are pretty much struggling a lot financially. Some of them are even what some economists call economic or financial zombies, right? Like they're just alive because of state subsidies. So again, like we shouldn't just copy them now just because they copied us back in the day and they decided to, you know, to up their game. Like it doesn't mean that we have to go for a full industrial strategy. I mean, industrial strategy also, it can waste a lot of resources. It can lead to a lot of leverage in our own financial institutions. So I'd say we need to accompany our strategy through an industrial strategy, especially for the security aspects, and that's very important, especially for the next few years. But we need to focus on what we've always done best, which is organic growth, and not just, you know, just setting up like objectives and targets the way those countries are doing, I would say.
In my opinion, everything that was said, of course I agree, is everything starts with a very basic strategy. China had this strategy. I remember in the year 1996, I was teacher at the Spanish staff school, and we had a Chinese student. Then we were friends. And I asked the Chinese student, but who is your enemy? Because we thought there were no enemies, because globalization, everyone is friends. And he said, our enemy? US, of course, was the answer. So they had a strategy because they thought it's just a question of time that we'll have a problem with US. We had no strategy because we thought globalization will make us all friends. China will democratize. Once they are a democracy, no problem with China. But they had a strategy. Now we are at the beginning of having a strategy in the European Union and in Europe, but only at the beginning. And still we lack clarity in this strategy. We have a lack of clarity. So one of the elements we have to introduce in the strategy, as you were stressing as well, is we need a strategy now. We are in a hurry. We cannot have a typical European strategy mind, which is everything goes slow. In fact, you were asking about the Draghi report. What is Draghi saying in the report? We have a problem. And we should know we have a problem. So the strategy should recognize we have a problem. We have to change something in the process so that we can have a clear strategy and a plan to solve the problem in this strategy.
Very good takeaway. Well, I think we are pressed with time, so no more time, but you will have the experts around. Now, I think let's give a big applause to the table, And now it's time to divide, but not because we are enemies, just because there are... Yes, we are going to take a picture. Yeah, but we are now going into two separate sessions, for different thematics. There will be a keynote speaker, then there will be different projects presenting, and finally there will be again a round table with the experts, so you can participate also and raise questions. So yeah. 1 second, I let that. Let me let the microphone. Because we are rushing here and there. We have all the journalists coming.
Magistral intervention to open the session, all about the latest developments in exploration technologies for ensuring the European raw material supply. The Professor Piercarlo is currently a professor of solid state physics at the University of Cagliari in Italy. He has been invited as a scientist at prestigious institutions such as the University of Grenoble, Universidad de Castilla-La Mancha, George August University, University of Ottawa, and Universidad Tecnológica Moldavan. His academic journey includes a PhD in physics from the University of Cagliari, where he later became an assistant professor and research fellow. His contribution to the material science and applied physics are significant, particularly in optics, optoelectronics, and the development of innovative materials. Indeed, he counts on multiple patents, and he has authored over 180 peer-reviewed publications, garnering about 3,000 citations. So please, Professor, the floor is yours.
Thank you so much. I don't know if I need...
Sorry. Is this one? Sorry.
Good afternoon. We are just few, but I hope that could be a very nice discussion. I mean, first of all, I would like to thank Santiago, Catalina, and for this very nice organization. So, actually, I'm a physicist, so it's a little bit different from the main topic because it's a material science. And my role here is to decrease the TRL of the discussion and to enter more in the technical part, let's say. So this is the reason because we talk about the latest discussion. So apart a very brief introduction of raw materials, because for sure we discussed very deeply today, so I don't want to bore you too much. And I would like to focalize while on the optical technique to explore the mining in the mining session, in the mining field. So one thing that I like always to introduce to the student, or even in general when we talk about the transition to low carbon economy, and so to low impact. In general, people say, okay, but I mean, with the electric car, we are safe. There is no more emission. And I mean, today we talk about the need of the European community, about the raw material and so on. But what is very important is that and we know, and you know better than me, that there is no free from CO2 emission, all these technique. Why? Because for what we said, I mean, the wind turbine cannot work without the rare earth, and to extract the rare earth, we need some emission. I mean, we need the emission. We have to transport also the electricity from one place to the other. So it's not true that is free from emission, all of this. So the transition, you have to pay something. And you have to pay something for what we say, I mean, of different materials. Is sometimes even in the lighting, that sometimes people didn't know that in this light, that is white light, we need rare earths. And we observe a white light just because we have the emission in green, red and blue region. And so we saturate and we see the white light. So rare earth and critical raw materials useful in several applications. Another point that is very interesting and was that today, the discussion of today was mainly on mining, absolutely, and it's true. When we start talking about critical raw materials, what was important is that the substitution was a very big, important field. I talked about 2014, we opened a commitment with Santiago, with other partners, about the substitution of critical raw materials. And it was interesting that today, the DG Grow manager that talked before said at about 80 European projects right now are on mining and only 5 on substitution. I suppose, to be honest, that one of them is one that started in 2020 where I was part of that. And was, sorry, is a little bit different from the main topic, then I return back. But it was interesting to note that in 2020, we applied and we obtained a European project to substitute vanadium in the flow cell batteries. And we substitute with copper. Now we see that copper is a critical raw material too. So we started, it was not a critical material, we arrived at the end and we use a different material. So the substitution is very, very difficult to achieve because you start very at the low base research and you have to arrive to high TRL and you have to think to all the aspect from this point of view. Anyway, so this is the point. So we have to move on the challenges to new and effective mining technologies. And as I told you, I want to decrease the TRL because today, after me, several projects already talk about a different way to explore. And I'm not so expert and all these projects are for sure much at very high level. I mean, technique that use the artificial intelligence, then other, I mean, the role to, I mean, all the connection, I mean, on the mining and I will say, to discuss the impact of the mining is very important. So what we want to discuss is new way to explore, something that is not totally already developed, totally. I mean, for sure, we can start from the base, but something from some level. And so, which are the advantages to use optical technique? First of all, they are non-invasive. But maybe for mining is not so important, but it has some impact in somehow. High precision. High precision means that we can arrive to a few microns if we want. I mean, it depends from the technology that we want to obtain, that we want to use, but very, very high precision. Then, the remote analysis. I mean, remote means that you can obtain spectra, you can obtain information from different meters. I mean, for sure, even hyperspectral analysis is an optical technique. But we want to use a different kind of optical technique. Hyperspectral analysis, you know better than me, that can work with very high level from distance. We want to, let's say, to use drone, for example. We don't need to arrive into the place, but we can monitor from some level. And then, for sure, the main objective is to arrive to identify the mineral. So now I want to introduce you some technique that some of them are already utilized. LIPS technique is already utilized, but in a different way. In general, is not in a remote way. We want to arrive to a remote way. How? With the technology improvement. Then the time-resolved luminescence, that is in somehow complementary to the LIPS. And then to use Raman spectroscopy. Raman spectroscopy for the geologists is something that they knew very well. But we'll see how we can improve in way to obtain a real remote analysis. So let's start from the beginning. I mean, very, very brief introduction about each of the technique, and then to enter into the details how we can apply it. I'll say the LIBS is laser-induced breakdown spectroscopy. What does it mean? That very quickly, just to introduce to the non-expert. I mean, you use a laser to excite the sample, I mean, to excite the mineral, and to obtain the emission from the sample. But let's say something more. I mean, the laser is a very powerful laser. How you can obtain a very powerful laser? Using a pulsed laser. It means that the laser pulse is in few nanoseconds. This means that if the laser has some millijoule, the power density, the power on the sample, is in the order of magnitude of megawatt. This means that you have a very high plasma, the very hot plasma that is generated in this region. So the inner electrons are excited, and when the pulse finishes, they return back. This means that is only the inner electron that emit light. So it means that every element has a fingerprint of the emission. So you can identify immediately from the emission of the plasma, so not from the structure of the materials, but it's just an elemental analysis. So you know the element, not how it's bonded to the other, but you know which are the elements in this sample. So LIBS is already utilized from different point of view, and so this is just an example. I mean, here you have the image and a map of the different elements. You don't know how they are bonded each other, but you know which of them are present in the sample. So probably here exactly is better showed in a color map. So higher is the color, I mean, and the red means that you have a much higher intensity of lithium in this case, respect, for example, to sodium here. And so on. The point is that LIBS is already well known, but work in general in this way. Is portable, it's compact, it works finely, but for the remote analysis, it doesn't work very well. Why? First of all, for the laser. The laser means a pulsed laser. In general, the technology till now arrived to something that is a little bit heavy and difficult to obtain. And even the, how we can say, the acquiring system of the light is sometimes too heavy to be utilized in remote analysis. Another point is that even the resolution, the spatial, the resolution depends on the distance. And why this? This is done by the fluctuation. I mean, you have to be very precise in the focalization of the sample. And so this hampered in somehow the application of LIBS to remote analysis in this way. But, what we want to do, and we are trying to do and will do for sure, is a system like this. So this is the pulsed laser. The light arrived there and is monitored in even the image. Then the image, I mean, is a way, let's say, we want to develop in somehow, a way to monitor pulse by pulse in somehow where the spot of the laser is arriving. In this way, we can obtain a higher resolution because we know where the laser is arriving on the sample. If I arrive here, I'll see immediately here. If I arrive there, I'll see here. And so I can match the image with the laser pulse. This increases the resolution. Then, how I can overlap the problem with the weight, but with the technological. I mean, the problem from a technological point is already solved. This is a laser, a neodymium YAG, so a pulsed laser that we already have in our labs. That is something stay more or less is like this. So the dimension decrease a lot. Then this is the spectrograph part. So something that stay in your hands can obtain the light that return back. So in a system very compact that we already have we are developing in our labs, you can obtain the leaps from a remote. You can check exactly, I mean, the resolution go down to something like 0.2 millimeters for every meter from the sample. So, I mean, if you are not interested to micron, it could be as a nice way to obtain a nice result. And in this way, you can obtain a very high resolution and very low weight. So, if LIBS is already utilized, the time-resolved luminescence is something that in mining is not very well explored. Why it is? Okay, time-resolved luminescence, I mean, the luminescence is something that we know. This light works for luminescence. This means that I send some photons to our sample, the sample go back you a different light. Okay, the time-resolved work more or less in a similar way like LIBS, because you work with pulsed laser. So this is the pulse of each laser, of the laser, and then you see how the material relaxes after the pulse. In this case, the neodymium YAG is the same. The power is much less. So the sample does not form a plasma, but that just is the outer electrons that is excited, and when they relax, give you back a luminescence that depends from elements to elements. This is the delay, I mean, the times that the system needs to be relaxed in the order of some nanoseconds, okay, in this case 20 nanoseconds, and so you have the pulse, 20 nanoseconds, and you see what happened. And okay. So in this way, you can arrive to very, very, very low concentration if you are interested. I mean, because if LIBS arrive to some hundreds of ppms or something like that, if you are lucky, it depends from the element to element. In this case, you can go down to part per 0.5 part per billion, something like that. So very, very low concentration if you are interested. The point is that not all the elements have some emission. The good is that you can even, I mean, divide between different kind of emission. Why? How? Looking at the time in which they relax. This is just an example in which this comes from cerium that decrease very quickly. This emission comes from terbium. So if you look at very short pulse, so 10 nanoseconds, you observe only cerium. If you increase your time scale, you see the terbium in the same place, with the same measurement. So it's a different way to see different elements. The problem is that not all the elements make some emission. So in general, rare earth are very nice. And by the way, the rare earth emit always in the same way. So it doesn't matter if terbium is in a kind of material or in a different matrix. It emits always in the same way. While other elements, like the transition metal, the emission depends from the matrix in which they are embedded. So the resolution, you can go down very, very at low concentration, but you have to study a little bit. So if LIBS and time resolved give you information on the elements that you have, but not exactly on the structure, Raman spectroscopy give you on only the structure. I mean, not only the element and the structure. So, without entering too much into the details about, about the mechanism, the physical mechanism. The only point that I would like to stress is that the signal is very weak. The sample is totally preserved with Raman spectroscopy because work in the vibrational. So, if one is an inner electron shell, the other is outer electron shell, Raman is in the vibrational mode. So it means that every matrix, every mineral, if you want to talk about mineral, have a different different fingerprint, a different Raman spectra. Okay, and it's okay. It's already utilized in mining. There is this, just for give you some idea, this roof can be found very easily on the web. Is a database with a lot of minerals. And there are very compact already on the market Raman system. The point is that, first of all, the luminescence totally overlap the Raman signal, because the Raman signal is very, very weak. So if you have any impurities, be sure that you cannot obtain the Raman signal. Okay, there is a way to avoid the luminescence. Change the excitation range. Why? Because in theory, just theory, because in practice everything, I mean, even a deep theory say you something a little bit different, but as a first level, you can observe the same Raman spectra using a different laser. Another point that is very important, in Raman, right now, only continuous laser is utilized. So not pulsed laser, and this is the point. So weak signal. The other point is that in general you work in labs. I mean, only when I work in my lab, all the lights are switched off, and you have to be you must be very, very careful that the light doesn't enter into your labs. And so it means it's difficult for mining to, I mean, you have to do in the night. No, I don't think that it works as well. So it's very difficult. And in general, it's a micro system. I mean, very high resolution, but very low distance. And how we can use the Raman in mining. And this is something that we want to explore in the Explore project, something, is to mix what we already discussed today. I mean, to use not a continuous laser, but a time-resolved laser, a pulsed, or better, a pulsed laser, and work on the different time behavior of the materials. What does it mean? The vibrational element is very fast, but very fast, much faster than the normal luminescence. This means that if I pulse in few nanoseconds, few means 2, 1, 2, 3, it depends from the laser that you have. Be sure that after 1 nanosecond, 2 nanoseconds, the Raman spectra is already obtained, while luminescence is still flat. So, this means that, first of all, you can use the normal light. Now we are obtaining the first Raman spectra in totally normal condition, with light switched on, because this light is continuous. It's like a normal background, and you can easily erase from the system. Okay. Then what you can use, different system to use different excitation, even to avoid the luminescence. But even in that case, if you have luminescence of the order of microseconds, is not a problem at all, because you are working a very few. So if you merge all this information in the technique that we talked today, I mean, you obtain the elemental analysis by using the same system, you don't have to use a different system. A neodymium yak and a very compact way to obtain back the light that I explained today with LIBS, but is exactly the same with time resolved luminescence. Then there is just a matter of very easy, but I don't want to bore you too much. Neodymium yak emit in the infrared region, but if you take the second, third, or the fourth harmonic, you can arrive till the UV range to excite the luminescence. And so with the same system, you can obtain this one. Then you have some elemental analysis that help you to find the Raman fingerprint, the Raman spectra, using, again, the same excitation source. So we can use the same in the same compact system, we obtain LIBS, time resolved luminescence, and even Raman. Then I can enter more into detail about the possibility that we have merging all these systems, but I don't want to borrow and maybe just answer to your question. And because I think that we are at the end of the, and for sure we can, the good is to give you and to explore a different way, to a different instrumentation to obtain at the different level some information from the ground and so to be applied. So I thank you again for the time. I don't know absolutely how long I was there, and if you need some contacts for any question, I'm happy to share what I know. Yeah, thank you so much.
Thanks, Professor, for the interesting explanation about the technology. Thank you very much. So I'm sure you have questions about the presentation of the professor, but I suggest to keep your questions for the coffee, for the lunch break. We will have time to do some kind of networking because we are a little behind of the schedule. So please keep your questions in mind. So now it's time to start with the explanation about the successful European projects working on exploration technologies. And we are happy to do the welcome to Valantis Tsiakos. He's going to present the TerraVision project. He's a scientific project manager at the Institute of Communication and Computer Systems of the National Technical University of Athens. So please, Valantis, welcome. Sorry, just a kind reminder. Please be attached to the 8 minutes per project presentation.
For sure, for sure. Okay, thanks a lot. Okay.
This one, right?
Yes, yes, thank you. So, hello from my side. My name is Valantis Tsiakos. I'm from the Institute of Communication and Computer Systems. Our research group, ISMC group, and also the division that I'm responsible for, the Earth Observation and Environmental Monitoring, leads the TerraVision project. So, TerraVision started this year, and the overall goal of the project is to implement various Earth observation-based solutions in order to enhance the entire critical raw materials value chain and be able to provide all this information, all these services in the context of an aggregated platform, of an aggregated system, including different innovations. So essentially the project, we are working a lot with different data sources. The primary objective is to be able to exploit data from the Copernicus ecosystem that is quite being promoted from the Commission, along with other data sources. We work towards implementing various pipelines in order to implement analysis-ready data. So analysis-ready data involves not only data coming from satellites, but also data coming from in situ sensors or aerial and airborne data sources. And evaluate different aspects in terms of the operations of the mines, for instance, checking hazard assessment, instability aspects, but exploration, and so on. I will provide more information later on. And so we are a consortium of 15 partners from 6 countries. The project has a duration of 4 years. And currently, we are in the phase that we are moving in the development of the system after we have designed it. So here you can see an overview of our concept on what we are working with. So you can see that there are different data sources available from satellite, from in situ, or for aerial and airborne platforms. The idea is to be able to synthesize this data through advanced analysis and fusion techniques, being to implement what we would like to say in the context of the project, a standardized spectral knowledge base, and then implement services, as you can see, in terms of the raw material exploration to be able to identify new areas of interest for the mining companies. We have use cases focusing on monitoring the extraction rate in the open cast mining, monitoring secondary raw materials and upscaling this information at the EU level, and then also assessing surface deformation and also hazard assessment that it is of interest for the mining stakeholders. The project it is being demonstrated and validated in 6 sites in 3 mining companies. We have a use case in Greece with Ternamag, and we are focusing mainly on magnesium in the context of this application case. With different characteristics in each site. We have a case in Spain, Andalusia, with Arcis. There, some of the key elements that are of interest are cobalt, copper, lead, zinc, and also we have a case with Canteras, Montevive, Spain, where we are focusing on strontium. So, just to give you a flavor mainly on what we see relevant in the context of exploration services, one of the important parts of all the activities that we are discussing is how we are able to collect efficiently data and apply also different pre-processing services. So the project is really invested on that direction. We are utilizing geophysical data, satellite data, focusing on hyperspectral, but also, since it was a requirement for the topic, we evaluate also multispectral data sources. In situ sensors, spectrometers, XRF, also Raman spectroscopy, we are utilizing in the context of the project. And the idea is to be able to provide, let's say, analysis-ready data that can be easily utilized in the context of the algorithms. Apply, all the necessary pre-processing of the data so as to have the flexibility to utilize in the context of monitoring applications. Another service or component that we see that is quite relevant in the context of the monitoring, I would say it is what we call spatial augmentation. Essentially, the idea of the project is to be able to uptake as much as possible the Earth observation data. So Earth observation data have the limitation of the resolution, right? This is what it hinders their applicability in most of the cases in such applications. So, for instance, some of the algorithms or some of the techniques that we are applying, it is on thermal data, on, let's say, we call a technique thermal sharpening. Essentially, we apply fusion between different Sentinel data providers in order to increase the resolution of Sentinel-3 SLSTR datasets. That is, it can be of interest both for the exploration cases, but also in cases that we assess the environmental performance in the mines. And also, we try to augment the resolution of hyperspectral data, like the ones that we are collecting from Prisma and Nmap. For instance, one of the use cases that we are going to do in the context of Prisma project, it involves a fusion between the parcomagnetic band provided by the provider with the hyperspectral bands, so as to improve the resolution of the data. This is just 2 examples that I'm mentioning in the context of this presentation. And then in the context of the exploration service, the idea behind this is that we utilize diverse data sources. I mean, both in situ data coming from spectroscopy in the context and satellite data in the context of implementing a standardized spectral library, as we said. So essentially, we need to utilize data coming both from the mining sites, as we involve in the project, but also try to explore openly available spectral libraries and provide a unified product that can be used in the context of mapping and applied in the industry. Then we will apply this spectral library along with data-driven approaches in order to characterize and map geological feature of interest, and essentially apply what we have, as we say, prospectivity mapping, essentially being able to predict the likelihood of finding mineral deposits. Some conclusions. I mean, what we see as key element for this part, it is the ability to combine and fuse all these heterogeneous data sources from all these providers, both in situ, aerial, and satellite data, so as to be able to facilitate the monitoring the mines. And also some of the collaboration opportunities perhaps that we should investigate with the other project are around how we can harmonize effectively our data, so that's going to be utilized in the context of other applications. How data sharing or knowledge exchange could work, I mean, between the different projects that are involved in this domain, and what, let's say, alignment or complementarity could be applied in the context of the monitoring approaches. And I think that I'm just on time. Thank you.
Thanks, Valentin, for the presentation. So now is the turn for EIS. So Juha Marti is going to present the project. He is senior specialist at the Geological Survey of Finland. So now the floor is yours.
Okay. Yes, thank you. Okay, yes. Like here, yeah. Okay. Yes, hello, and thank you for the invitation. I'm proud to be here and present the Exploration Information System project just very shortly. But first I have to show this figure it's only one slide from Geological Survey of Finland. We are operating under Ministry of Economic Affairs and Employment, and we have at the moment over 300 ongoing research projects, which topics are varying from deep mineral exploration to mineral processing, and also to circular economy is important for us. And most of these, or many of these, are also related to critical raw materials. And we have about 30 Horizon Europe projects at the moment. And well, Exploration Information System, this is a 3-year project funded by the Horizon Europe, and it will develop new data analysis method by applying artificial intelligence, machine learning into mineral prospectivity mapping together with new geomodels and mineral systems modeling. And we have partners from 6 countries, EU countries, and 2 partners outside EU, Brazil and South Africa. We have 2 partners from Spain. They are CSIC and then Coprelas Cruces. And GTK is leading this work. And my role in this project is I'm actually leading the stakeholder work package, so this is perfect place for me to network with you guys. So ACE will develop the so-called ACE toolkit and ACE cookies wizard. And this will be exploration tools, and they will be fully open source, and they will provide critical information for the mining sector, junior companies, and geoscientists. And these tools are also developed in the ACE. They aim to reduce the impact of environmental footprint And it's done mainly by using as much as possible good geodata, previous geodata. And of course, with these tools, we aim to more precisely target the exploration activities. So they will be faster and more time-saving also. And of course, raising the awareness is important in ACE. So this is the management group. Vesa Nykänen, research professor from GTK's scientific coordinator, and Hafsa Munia from GTK's the project manager. And we have also very excellent scientific advisory board. Karen Hanghoy, director of the British Geological Survey, UK, is on board of that. And also Professor Maher Yousefi from Malaya University, who was actually one of the first who started to think about this mineral systems modeling. So, exploration information system, it combines mineral system model approach and mineral prospectivity modeling. And one of the backbones of this whole system is the mineral systems library, which collects all the necessary information and critical criteria into mappable parameters. So, for example, fluid source, metal sources, and ACE is concentrating on pre-processing of the data, classification, rescaling, and because this is very important part of the ACE process, because if you have bad data, then you get also bad results there. And of course, data integration is important. And the final outcome would be like new exploration targets. This is like showing in one picture what we are doing there. And well, ACE toolkit, that is a set of data and tools for data pre-processing, exploratory analysis, predictive modeling, and results evaluation. And then this ACE Wizard and ACE Cookies plugin, it sort of combines all together, and it will be a user-friendly interface in the cookies with the ACE Wizard. And this is, as I said, this is fully open tools for everyone. And these are the mineral systems that are modeled in the ACE. And for example, from Spain, we have a VMS deposit cobalt minerals, Las Cruces, and then we have also related to lithium, tin, tantalum, tungsten minerals. In granite pegmatite systems, we have several sites in western Iberia. And of course, Caliper, the most important lithium deposit, which is about to become a mine, is with us. Here's a map of those test sites. And then a few words about the ACE toolkit. So I'm not an expert on these matters, but if you want to know more, then just talk to me and I will give you the right persons. And by the way, Fernando Tornos is sitting there, and Fernando is also part of the ACE project and CSIC. So ACE toolkit, it's a comprehensive Python package for mineral prospectivity mapping and analysis, and you can see the links there. They will direct you to this GitHub Python library for mineral prospectivity mapping. And then a few words about networking. Last year we had a so-called EU Supercluster Geo Conference in Rovaniemi, Finland, and we had like 140 participants on site, and it was altogether 23 EU-funded projects, and the University of Queensland were organizing this. And then we had a webinar with the MineArc project, which is actually funded by the US State Department. It's a kind of interesting funding form. And near future networking, this is important for us. In upcoming Raw Materials Week in Brussels, there will be a session on mineral exploration called Strategic Approaches to Raw Materials Exploration. You can see the program on the right side, and it's organized by DC Grow and ACE Project. And by the way, we have 3 speakers from Australia there also. So like Geoscience Australia and University of Queensland, they will be talking there. And that it's important for us, I mean, the cooperation with Grecian area. Then in Rovaniemi, June 2025, there will be OECD mining regions and cities meeting. And in connection with that, there will be so-called supercluster second edition. And of course, we are open. We will be starting a new deep exploration project undercover next year, and we are of course open for collaboration with other projects, and including the new deep exploration project, Deep Pit, Explore, and Minotaur. And well, future work, I have still 4 seconds. Well, I only say that it's after completion of this project, the ACE will be a collection of open source software tools for semi-automated exploration targeting. Thank you.
Thanks, Juha, for your presentation. Now the turn is for Golden Ram. Golden Ram will be presented online. So I'm going to give the floor to Marco Pavola. He's senior scientist and project manager at the Technical Research Center of Finland. He should share. So Marco is sharing the screen.
Okay, can you
Welcome,
hear
Marco.
me at all? Maybe you can hear me?
Yeah, we can hear you.
Okay, can you see now the slideshow? Is the slideshow visible?
No, we cannot see your slides.
Sorry, I'm more used to the Teams. So this
Now you need just to put the complete screen, and it will be ready. Okay,
now you can see
it's
the
perfect.
slideshow.
Yeah.
Yes. Okay, sorry for this small. So indeed, my name is Marco Pavola, and I'm from the Technical Research Center of Finland. And I'm actually nowadays a principal scientist, so I must tell Marko Savolainen, who has sent me my information, that this is wrong. So anyway, it's not a big thing. So my background is in control engineering, so I'm adjunct professor at University of Oulu in control engineering, and now I work with the optical measurements team. And I'm here on behalf of Marko Savolainen, who fell ill, unfortunately. And with a short notice, I prepared a small presentation for you. And unfortunately, I won't be there now in present because of this schedule, but please send me emails and questions afterwards if you're interested on what you see. And let's get started. So Golden Ram platform is an Earth observation platform that is a successful project of the GoldenEye platform project that ended last year. So GoldenEye ended at TRL6 mostly, and now we are taking this platform to higher TRL level, and we are aiming to markets after the project. So it is very advanced technically, very mature in a sense. So we have 13 partners and 3 years. We started in the beginning of this year, and it's a 6.7 million euros. And our platform digests all kind of data from various sources, satellites, drones, and aerial sensing in general, and proximal sensing, and we have the platform development included. So we have a very multidisciplinary consortium here in the project. So we have ICT expertise, we have geological surveys included, we have measurement expertise and business modeling and so on. So it's a very challenging project that I'm lucky to lead. It's a balanced consortium, so we have 4 end users and 4 academic and research centers and 5 SMEs in the project. And then Yeah, of course, we all know the background quite well, so why the critical raw materials are needed, so maybe we can go forward to what is kind of our focal point in the project. So in order to support the mining with the critical raw materials, we are focusing on the information exchange transformation. And I think that here very focal thing is the new technologies in the cloud processing, data analytics, IT in general, and AI technologies. So combined with the mining domain understanding and geological surveys and expertise from there, I think we can create a very powerful set of tools for the mining industry and for the academic users and the public authorities. So this way we have an option to really multiply the users and scale up the research and commercial activities that are taking place. So this is very important. And indeed, starting from the GoldenEye project, we have been focusing on the compatibility and interoperability with these platform technologies so that we can even bring and send data to some other commercial platforms that are just supporting the standards. So we are very open and we want to be able to share the results widely. Then the application areas that we have in the project. So we have exploration, operation and safety, environmental application, and prospecting and exploitation applications. And of course, all of these are very important, and we have geological surveys leading part of them, so from Germany and Finland, and also VTT is leading the application development in some of the work packages. We have their mineral mapping, for example, GTK is providing mineral prospectivity mapping, and then we have CRM deposits from Romania, and so on. And quite interestingly, we have also prospecting and exploitation application partner from Ukraine. And in this project, we are building an access to their databases and electronic maps what comes to critical minerals. And I'm happy to say that despite of this very sad situation, the collaboration is working well, and our Ukrainian partners have been able to work with us. So I hope that this part of the project will also support the strategic partnerships and roadmaps that European Union has. Then the technologies, as I mentioned, we have satellite sensing, and people always ask me what kind of satellite data do you ingest, and I can now safely say that almost everything, as long as the standards are supported, and if needed, we can build some more methods to bring in data. So at the core of this platform is the data pre-processing algorithms that can take all kinds of data in and homogenize it in terms of time and space, so that when we start doing the AI or other knowledge extraction algorithms, the results are meaningful. So this is there right from the beginning. And in aerial sensing, we have drones, we have RGB and hyperspectral drones, for example, and then we have proximal sensors where we have natural data that is available at the mines, and also we collect our own. And then Raman spectroscopy has been mentioned today, and I can shortly advertise that we have been working with time-gated Raman spectroscopy already for a while, and we have application for proximal sensing and also for the beneficiation plans. So if somebody is interested, please contact me. We can check what has been done already. So it works quite well with fluorescent samples, for example. Then we have the natural language processing, because the main idea is that the platform is easy to access and easy to use. By the way, demo is already available. If you are interested, contact me. So the operator does not need to know anything about the complexity about the cloud computing or data analytics. Just use natural language for example, show me critical raw materials in Finland. This is a bit naive, but that is the idea. And then we have 6 field trials in Romania, Sweden, Portugal, Finland, and Ukraine. And I don't have time to go to the details, but we covered much of the value chain from the mines that are in the starting stage to the closure. So it's a good set of case examples that we are providing. And thanks a lot. I think my time is up. So here you can see the consortium and
Thanks,
just send me
Marco.
the questions afterwards. Thanks a lot.
Thanks for being so tight to the time, and thanks for sure for your interesting presentation about Golden Ram. So now it's time for Deep Beat. So we have today to Peter Mogurossi. He is the CEO from the Laser Consultant and the LC Inno Consultant International. So please, Peter, the floor is yours. I'm going to share the complete screen. Let me see if I can do it. Ali.
In the meantime, I can take
Yes, yeah.
Buenas tardes. Thank you for inviting this newborn baby of this community to this clustering event. Newborn, it means that we are just 2 weeks old. So this is a fresh new project and thank you. And I myself is also a kind of stranger here because I am not from the sector. However, I enjoyed very much the introductory or the keynote because that was about material sciences and laser technology, and this is what my background is. So I'm a laser physicist used to work as a material scientist. So what DBeat is, here is some technical details. It's a RIA project, and the project coordinator is our German partner, the Helmholtz-Zentrum from Dresden. And it's close to 5 million projects. And as you can see, it just started recently, and it will take 3 years. Here we have a large number of partners. I mean, the usual geographical setup. I mean, Finland, of course. Then we have the Czechs and the Germans. We have also associated partners, quite a good number of associated partners with various roles, and even we have overseas partners. Here is the geographical spread from, so I mean, blue lines show the partners and the black lines show the associated partners. Some of the associated partners provide technologies, the other associated partners provide test sites. Here are the main objectives of the project. As you can see, it is about the deep-seated deposits, and the aim is to develop geochemical methods for identifying these deep-seated deposits. Also, a key component of interdisciplinary, holistic, and sustainable approach. Very, very appealing expressions, which are very fashionable, but of course there is a very strong science behind. It's as it is interdisciplinary and even multidisciplinary geophysics, geochemistry, but also it is very important to take into account, as it was mentioned in the morning in the keynote speech, that the societal and social aspects. So the local communities are very much considered as a partner. And yeah, so we plan a very strong interaction with the local communities. So therefore, we organize public consultation events on all the 3 test sites. So here are some technical objectives: facilitate characterization of deposits, improve geochemical methods, accelerate geochemical data acquisition, and reduce exploration cost. This is very, very important, cost reduction, as it is a very capital-intensive sector, and raise awareness for the need of exploration activities in Europe. That is also in line in the morning keynote speech and the speeches, as well as with the roundtable thoughts and workflow. Here are the work packages. As you can see, it's a very simple structure. We have 2 horizontal work packages: the project management, which is necessary, and also this work package 5, which is exploitation, dissemination, and communication. And then we have 3 technical work packages which are related to the 3 test sites. So Saramäki is, of course, the Finnish test site. Erzgebirge, Krusznye-Hory, that is a border region between Germany and Czechia. And then we have also another Czech site, which is Hurki. Here is the concept. Probably we have too short time to introduce all the details about the but you can see that it considers from the treetop down to the deep mineral deposits, all the aspects and all the tectonic mineralization or ore bodies, concealed deposits are also targeted. Granitic intrusions with auroral metasomic zones, alteration halos around mineralization. So there are many aspects which are considered in this project. And you can see on the y-axis what are the spheres, like the various biosphere and even soil, hard rock parts are used to gain data. Here are the expected outcomes. I mean, I don't want to go too much in the details. You can read the slide yourself. And as with many other European projects, we have a very solid list of expected key exploitative results. And as I mentioned, that is expected results. So the reason why I don't want to go into that, because this is what we started to work on to get all these results, which can be not only explored but exploited as well. And this is what our responsibility is. And not only technical outcomes, but also some social and societal outcomes as well. And we, as ELSI, we are the partner for non-technical tasks. So what was presented before, the work package 5, which is exploitation, communication, and dissemination. And we shall take care of all this. So about the company itself, tomorrow morning there will be a session where I will introduce the activities and horizon-related activities of the company. Thank you so much.
Thanks, Peter, for the presentation of the bit. So now the floor is for Agemera. The project is going to be presented by Fernando Tornos. He's Professor of Research at the Instituto of Geociencias, CSIC. This is for you.
Okay, thanks. Well, first of all, thank you very much for inviting us to this interesting meeting. Unfortunately, the coordinator cannot be here, So a few days ago, he told me, since you are in metal mining hall, why you don't go to the meeting? So thank you. Well, Ajemira, as many, let me check how this goes. Yep. Okay. Well, it's another project oriented to exploration in Europe, innovative, non-invasive geophysical methodologies for mineral exploration. It's coordinated by the University of Oulu, and it has 20 partners from 11 different countries. Basically, the project tries to join or to merge geophysics, mineral system modeling, but it has a very strong component on the social and environmental problems of mineral exploration. The project will last till end of July of next year, so we are more or less in 2/3 parts of the project. We are starting to get interesting results. And here is the project in a very quick snapshot. Sorry, I have to put the glasses on. You want to read? Ah, no, it's here. Okay, basically it's trying to find new areas for critical raw materials in Europe, not the very classical ones, the very brownfields areas. The second is trying to also develop geophysical techniques that are have less social and environmental stress. I mean, usually, how you say, distal systems. And there are 3 work packages oriented to social and environmental aspects. These are mostly carried by universities that are parts of the project. I'm not really an expert in the topic. And finally, the project, as most of the European Union projects now, we try to accommodate what we are doing to the United Nations classifications. Basically, it's very easy. The project, it includes 1 work package on critical raw material potential, a second one on the impact of the critical raw material exploration in the green and digital transition, geophysics, integration, obviously dissemination, communication, and collaboration. What we try, and that's on the right-hand side, it's that what we try to show is that there are very good, very precise technical, geophysical techniques for exploration, including muons, including deep seismics, that means deep seismics, passive ones, that means they are, you don't use an active source, but you have just the passive noise of milling, road or traffic, and so on, so you don't need to use explosives. Improved genetic models. Let's go away from the typical systems in Europe and let's try to find something new, something different. I mean, most of the projects are dealing with very classical belts in Europe. And there are, as I said, 3 points oriented to the social aspects. I'm not going to get into them. I'm going to focus on the work package 1, is the one we are working in. And as I said, we have tried to go a bit away from what's going on in the classical belts of the Pyrite Belt or Ireland or the Finnish Scandinavian Shield. And we have tried to work both in the Balkans and Iberia, and as well as in Zambia. I didn't say that a key partner in the project is Zambia. They are being really helpful, very interesting, and it's one of the great countries in the world for doing mineral exploration. In the Balkans, we are working in some unusual IOCG systems that are very or high cobalt rich. They have not been almost explored. It's only some old mining, so we are trying to re-understand the systems. Azarel, as a representative of the platinum group minerals rich systems in the Balkans. The Balkans are alkaline systems. They are unusual porphyry systems, and they have a huge PGE potential. So, and also, something that people sometimes forget is that aluminium is a critical material. And in Europe, in the alpine belt of Europe, we have a lot of aluminium deposits that in the form of bauxite. They have not been investigated in the last times. So it's a belt that goes from the Pyrenees to Turkey, and we have used again the Balkans, Bosnia-Herzegovina as a target site. In Iberia, we started working some promising nickel, cobalt, copper systems in the Pyrite belt. Mining Matza, it's partner of the project. They drilled some big bodies with potential cobalt, nickel, and copper, but we have seen that there is no crustal contamination, so there are very little chances of finding nickel there. So we moved to a new deposit. El Moto is probably the next large target in Europe. It's a giant tungsten deposit, but the interesting thing is related to a porphyry system, absolutely new. You have here on the left, one typical porphyry, but instead of having chalcopyrite, you have wolframite. It's about 100 million tons with 0.4% tungsten oxide. So it's going to be a big project. We are trying to understand what's going on here. And also what we are working is with Hajimura is trying to develop a new exploration concept. In greenfields, first of all, try to define the zones of interest from the conceptual point of view. We have this area, which are the deposits or the mineral systems you can find here. In brownfields, well, we have a district where we know there are deposits. We are trying to predict which are the best traps for forming large, high-grade deposits. Also, discriminate between barren and mineralized units, not only igneous units, but sedimentary units, by lithochemistry, mineral chemistry, isotopes, geochronology, and also helping to interpret the geochemical, geophysical anomalies. There is a problem now with these high-resolution techniques, geophysical techniques, that you get too many anomalies. So the problem is how to filter so many anomalies so so you can target them. And the thing is, using concepts, saying, look, all this is noise, the really interesting one are these ones. And finally, when you're drilling, that means in the very, very late stages of exploration, use even the barren drill holes for detecting aureoles of subtle hydrothermal alteration. That's great. You have to finish. Okay, so what we want to do with this is, on one side, increase the chances of finding an ore body, and in the cheapest way, as was said before, and second, to decrease the social and environmental stress. If you don't drill so much, then obviously the stress in the environment and the stress in the people around the project will decrease significantly. I think that's it. Sorry. Yeah, if you need any more information on the project, Jari Joutsenvara, sorry, you have for my Finnish accent. If somebody's interested in Work Package 1 and mineral system modeling and so on, I will be around here and in the Metal Mining Hall. Thank you very much.
Thanks, Fernando, for the presentation. Thank you very much. So the floor is now for Multiminer. Multiminer is presenting online by Marit Middleton. I don't know if you prefer directly share the PPT here, or instead you want to share your screen?
I just started sharing. I hope it works.
Okay.
Just let me know when it shows up.
Perfect. It's working good. So please go ahead.
All right. Thank you so much. Good afternoon, everybody. My name is Marit Middleton. I work for the Geological Survey of Finland. And today my presentation is related to the Multiminer project, multi-source and multi-scale Earth observation and novel machine learning for mineral exploration and mine site monitoring. This is a 3.5-year project. We are about halfway. We are starting to have results, but I don't have too many here to present yet. So I will present to you the overall concept. This is about 4.5 million euro project and a research and innovation project. And as you can see with the name, we're especially focusing on algorithm development, how to process the Earth observation data for the mining sector. Just a second. Yeah, the background for this project, as so many of the other ones presented today, is providing new technologies for improving the self-sufficiency of Europe for critical raw materials, and also for producing them the sustainable way. And the multi-monitor proposes to improve the mineral exploration and mine site monitoring practices through our generic but highly innovative machine learning solutions. We utilize data from all different sources, from satellite platforms, airborne platforms, drone platforms, and also in-situ data. And we specifically develop unsupervised and weakly supervised machine learning technologies just for the fact that in these environments, the training data in the field is often scarce. And we're producing applications for different phases of the mining, starting from the exploration, going into the mine site monitoring, and then closure and rehabilitation. So who is Multiminer? This is our consortium. We have 12 partners and 1 associated partner. We have 7 research institutions, 2 academia, 1 consulting business, and 3 mining engineers. So we have interdisciplinary backgrounds in geology, remote sensing, and machine learning. And we are coordinating the project here from Rovaniemi. So what are we going to produce in the end? It's going to be a set of different kinds of algorithms and applications and maps people can use, and they will be all open source. That's the idea at this point. We will produce some highly innovative data interpretation algorithms and maps demonstrated at our 5 test sites across Europe. We will do a 3D digital twin of composition and volume of the tailing storage facilities to support the future utilization of tailing materials. We will produce some algorithms for automated interpretation of the European ground motion service products. We will produce algorithms and maps of dam stability and ground moisture. Also algorithms and spatial models for water quality and acid mine drainage, as well as algorithms and maps for revegetation status and atmospheric and surface dust monitoring. We have 5 test sites where we demonstrate the algorithms and how they work. 3 of them are active mining areas, such as the Ihalainen limestone quarry in southern Finland. We have the Haafvilsen area with magnesium production in Austria, and we have the multi-metal sources coming from Kalkidiki, Greece. We also have exploration happening over in Haafvilsen, Kalkidiki, and Kaluntieri in Greece, which Kaluntieri area is a public exploration site with the antimony as the main CRM. And besides all those 4, we also have an abandoned mine site in northern Greece called Kirki. So far, we have completed most of our field work for these demonstration purposes. We, for example, have been putting some soil moisture sensors over at the Ihalainen site to demonstrate the ground moisture monitoring and validate and calibrate the Earth observation data. We've done an INSAR flight there, for example. We developed some comprehensive sampling techniques for monitoring the vegetation status at the Haafvilsen, and that will be done from different kinds of Earth observation data, from satellite, optical data, and also some drone hyperspectral data acquisition and multispectral acquisition was done over there. What comes to the demonstration of the mineral mapping algorithms, field work has been done across 3 different sites right now. One of them is the Haafvilsen site, which is an exploration, mining and exploration site. For example, drone hyperspectral data was acquired there. The data was validated with the field spectroscopy, and samples were brought to laboratory for the spectral measurements with the visible, near-infrared shortwave, and long-wave infrared spectra. We utilize a set of all different kinds of multispectral, hyperspectral, and synthetic aperture radar data from all of these platforms, coming from satellite, going from low resolution to very high resolution. We also have the aerial imaging and also drone sensing and proximal sensing, as many of the other projects we've heard today. What I really like to advertise today is the clustering network that we provided or produced with many other projects called All-Calderam, S34I, M4 Mining, and HMERA. And the idea is to improve the impact of these projects, to utilize all the networks that the projects have to produce some common communication materials. So if your project is interested in joining this common network, please let us in. You can find us in LinkedIn with the word ISMC network. There's also a QR code in the corner if you're able to catch it. So that's all for me. Also, multi-miner project, you can find us in LinkedIn, on internet, and you can also email us if you have any questions. Thank you very much.
Thanks, Marit. Okay, and we are going to close the round of projects with S34I. It will be presented by Mercedes Suarez Barrios. She's professor of mineralogy at the University of Salamanca. I'm going to share.
Thank you. And this is, do you think that is possible without microphone? Online, okay. Yeah. Therefore, it's mandatory.
And this is for you.
Can I pass here? Yeah, also. But here? Okay. Yes. No, this is not. Sorry, excuse me. It's not this. Well, let me to introduce our project. This project has as a main goal the research and innovation of new methods to analyze Earth observation. And at that moment, I want to focus in that I consider that are our 3 strength points. Okay, the first is here, because we work in full mine life cycle, from the exploration to the closure and post-closure, including obviously the extraction phase. And the other 2 strengths are, one of them, the use of artificial intelligence in a, how to say, transversal way through the project. And finally, we consider social aspects from the beginning of the project, and at the last step when we will have a roadmap for all people interested in mining activities, different stakeholders, policymakers, etc. And this project, as I said, want to explore and prototype new methods to analyze Earth observation, because there are many data sets that are still underexploited. These data sets come from different European missions. And obviously, as in the other projects that we have here, with a final objective to contribute to mining green transformation and circular economy and the critical raw materials knowledge in the European countries. Okay, our consortium is coordinated by Porto University, by Professor Ana Claudia Teodoro, and we are partners from 12 different countries. We are 19 partners, and we consider that our consortium is very well balanced between industrial and research profile, because as you can see here, we have partners that come from the different companies, technological companies, also stakeholders, people from academia, from 5 universities, 2 national geological surveys, and also other organizations or mining cluster. Okay, related to this main goal, we have a different specific objective. In our proposal, we calculate the number of data sets, services, new methods that we, in principle, are able to develop, okay? At that moment, after 20 months working in this project, we can say that these objectives are achieved. In fact, we have more than 40 new methods, and the open data sets, some of them are already available in Zenodo, only looking for the S34I, okay? And it goes okay. The organization of the project is here. We have 6 work packages. We consider the social aspect with an important number of tasks related to this point that correspond to work package 2. The big part of the works correspond to work package 3. Now is finished, because now we are working in the next step, that is validation of these all new methods that we already have developed, and this corresponds to work package 4 and especially work package 5. And finally, work package 6 that includes different tasks related to communication, dissemination, and whatever, but with one very, very important mission, that is to develop this roadmap at the end of our project. Because with this roadmap, all potential users, all people interested in different moments of the mining activity will have information on the most adequate methods to develop the activities, or for policymakers, etc. Well, our work related to different pilots in different phases of this life cycle of the activity in the mine. In the exploration phase, we study a deposit of critical raw materials at the north of the Iberian Peninsula, very few known on the geology, but we use this kind of data altogether, a spectral library, data from flights for hyperspectral data, and also for LiDAR data, and obviously satellite data. A very innovative part of our project is this, because we study shallow water. The leader of this part of the work is here, my colleague Javier, and this is developed in Rías Baixas, which is at the northwest of the peninsula, of the Iberian Peninsula, and the type of data is similar, but in this case we also have underwater hyperspectral imagery that is really novel. In the extraction phase, that is in Gamma, Austria, sorry, I go speak because only 2 minutes more. Here we have the kind of data that are worked together with an objective that is the continuous monitoring of ground instability, stockpile volume, and also a volumetric map of mining waste. And for closure and post-closure phases, there are 2 pilots, one in Finland and other in Germany. In these two cases, these pilots are in areas with great mining activity that now influence the quality of waters around these areas. The kind of data that they work are data from analysis and sample studies and whatever, but also imaginary both from drone and satellites, with the same objective in these two cases, that is to be able to elaborate ASIS mine drainage maps. This is the other area in Germany, an area in which the number of open pits and mining activities is huge. And okay, and finally, this last minute to talk about the participation of my university in this project. For Spanish people, sorry, he venido a hablar de mi libro. We collaborate developing the spectral library for Aralmo pilot. We study almost 1,000 of samples to have this very wide spectral library, and from this to develop the spectral signature that we relate with the contents in cobalt. And that is here you have the contact for a coordinator and project manager, and also my email. Okay, thank you very much. Y en tiempo. No me lo puedo creer.
Thanks, Mercedes, for the presentation of the project. So now we close the project round. And for closing also the session, we have the panel discussion. It will be moderated by Almudena Sanchez Gonzalez. She is the Business Development Executive at GMV. Her academic journey includes a PhD in fault-tolerant, distributed and embedded real-time systems from the Universidad Politécnica de Madrid, followed by an executive MBA. Almudena is gathering more than 30 years of international working experience in technology in the innovative markets. So please, Almudena. And I want also to invite the speakers of the projects to the round table.
So while I was struggling to put another chair, you know, because I thought you were going to sit there. It's okay. All right. So okay. So so good morning to everyone, and yeah, thank you all attendees here in Seville, also on remote. So thank you for all exclusive panelists, very good team here today. And also thank you the organizers for making possible this event, and also allowing me to drive or to chair this nice panel. So, well, my name is Almudena Sanchez. I'm responsible today of GMB R&D. And as a technological company, we are a group, a technological group with a global footprint. We have the roots on space, and we derive added value services and products for different verticals. In particular, we have made in the last years investments and collaborative research for the support of mining industries. And in this respect, I would like to start with a figure that comes from renowned sources that says that total carbon emissions from steel, aluminium, copper, nickel, and cobalt output is 13.5% of global carbon dioxide emissions. And with this, having this in mind, and consider all that has been already presented by the different projects, we have seen that, in particular, satellites, Earth observation is one of those sources of information that gives an answer and gives support. Of course, having this background on space, I would like to highlight the importance of Copernicus assets, the Sentinels that provides free of charge images for all mining industries. So that's there for use and for exploit. So obviously, Earth observation takes an important role in this decarbonation journey of the mining industries. And of course, exploration is one of those critical phases for the mining industries. And many of the projects has already presented some results or preliminary results, depends on where they are in the journey. So I would like to start with this exploration panel, focusing on perhaps which are the biggest, let's say, the biggest challenges for the industry. So that will be a couple of questions for all the panelists, which are the biggest challenges that is facing the mining industry, and also why they are often overlooked. So that will be a kind of a very quick question for all of you, so 30 seconds each, and we will continue afterwards. So I don't know, I think that you have also your mics. So who wishes to start, perhaps in the order?
This is working. No?
Okay.
Okay, yeah. Yeah, 30 seconds. I was thinking this question, and I think it's so-called resource scarcity. We often heard, and we heard today also that Europe is depending on external imports of the critical raw materials, but in fact, Europe has resources, and large parts of Europe has not been studied yet. I mean the deeper parts of the European continent. That's my view on this.
Okay, next.
Yeah, from my side, I would say in EU we have different, let's say, regulatory requirements, right? I mean, the mining companies have to comply with different regulations, with different policies, both at the general level and also national level. And on the other hand, they need to, let's say, to maximize and optimize their operations, right? So to find, let's say, the balance in these aspects, allowing the companies to be able to abide by the regulations, and on the other hand, enable them to utilize the different tools in order to improve their processes and maximize, let's say, their potential. I think it is, and how you're able to utilize these digital tools, it is one big challenge for them.
Okay. To try to say different things, because I agree with you, 2 points very important from my view are, one of them, very well known, related to social acceptance, is the big challenge, because if we have this problem to start, after is really difficult. And the second, in my case, I have limited knowledge of the activity around the European countries, is that this kind of mining companies are, how to say, they have inertia to actualize the technology, the new methods. We can work in new methods, develop a lot of different things, but the sector needs a long time to incorporate them. And that's for it.
Okay. Okay, I think you have said almost everything. I think I would like to emphasize something, is that Europe has been mined for 6,000 years. It's really difficult to find a new cropping out deposits, and we have to go deep. Now, probably, many people say that it's difficult to find a deposit above 500 meters depth. Perhaps Magdalena in the Parrot Belt has been the big exception in the last years. But we need to increase exploration. I mean, it's something I feel when you come to this meetings that, okay, we realize that there is a problem in Europe. And the first question is, can we have self-supply? Probably not. In some critical materials like tungsten, perhaps niobium, you can attain self-supply, but we have to go outside Europe. And not being as aggressive as the Chinese, but we need some kind of partnership with third countries so we can secure supply. This morning at roundtable, the Colonel was speaking about stockpiles. I don't know if in Europe you can find a place where to have a large stockpile like the big in the US. The second problem that we have in Europe is, as Mercedes said, the social problem. I mean, we are a highly populated area, so people are not very happy with having a mine nearby, even with the social and economic benefits. And the third point, and for me is the critical one, is the administrative stuff. Too much legislation, too slow, so that discourages companies to come to Europe. We have to be realistic. I mean, it's much easier to go exploring to Australia, to Canada, than coming to Europe. And if we have been mined for a long time, that means even less attractive. So I think that sometimes mining companies coming to Europe are like heroes.
Yes. A couple of my thoughts were already killed, so I have to come up with something new, which is coming from my background. What I can see, that especially in Horizon projects or many other R&D-driven projects, that excellent technologies are developed by public research organizations, universities, research institutes as well, and to take these technologies to the companies, to take it into commercialization phase where we need a strong commitment from the companies. There is a serious gap in between. And I believe that should be somehow covered, and that is what our role could be in this context. So this is one thing. The other, I fully agree with the societal that I also emphasized in my presentation, that societal as well as social, so the communities, so individuals, communities, very strong green, sometimes I call it dark green, considerations. We call them dark green considerations. So that is not that is always a problem. And the more north you go, the green is getting darker. So it's that could be also a very serious problem. Thank you.
All right. So I think that we have tackled environmental or issues with administrative or regulations. We have tackled these technological issues and research, outcome uptake, and also importantly aspects of social pressures, but also these geopolitical risks that has been also mentioned this morning. But then having this in mind and considering also the context of each of your projects, so perhaps starting with, perhaps Valentis, considering that your project is using Earth observation, you have explained it that well, to address the environmental challenges, how your project will tackle such kind of challenges.
Essentially, what we are trying to do is to utilize Earth observation data, particularly streams coming from Copernicus, so as to be able to monitor the impact of mining activities, both in the environment in terms of the soil of the land. I mean, monitor changes in land cover or changes in vegetation health, impact on air pollution. Right, I mean through the activities taking place during the operations, and also in the water, potential leakages that may affect from the activities of the mines. So Copernicus data provide really good resources to that extent, right? I mean, and what we try to do beyond, I mean, the current monitoring capabilities, it is to augment this data, improve the resolution of the resources by, I presented some concept about spatiotemporal augmentation of the data, how you are able to combine, for instance, different sources of data or within only satellite data, like with Sentinel-5P for emission monitoring, along with situ data available in the field, in order to have a better basis for the monitoring of the impact of the activities. Because in situ data are always a valuable resource, but due to their cost, I mean, you cannot cover everything with the situ data, and you cannot have the advantages that we have with the satellite data in terms of the monitoring. So our approach is around that part.
Very good. Thank you so much. Let me then switch to perhaps Juha or Ace. Following your presentation before, with integration of artificial intelligence, machine learning methods, etc., these techniques, this is applied to mineral prospectivity. So from this perspective and context of your project, how do you challenge these main four main challenges that has been mentioned?
Yeah, actually, it starts already from the building of a consortium. And when it was research professor Vesa Nykänen from GTK and other key people like Fernando Torrens here, they started to think about there was a suitable call, and they started to think about the consortium. And they also thought about outside of the box. There is a specialized company on board of the ACE project, which is specializing in using machine learning and artificial intelligence. It's called GISPO, and this is their first project in the exploration or mining business. And this kind of thinking, I have heard many times that we should, when we are developing something new techniques, whether it's artificial intelligence related to machine learning or whatever, you should think about the companies who are not aware of our problems in exploration or exploration targeting. They could have good solutions for those problems, but we are not meeting each other. And this kind of there was a clustering event in Levi in Finland a couple of years ago, and there were some discussions with companies who were coming outside of the mining and exploration world. And this kind of thinking, I think this is needed more. I will not go into technical details of the machine learning because I'm not an expert on that, but this will be, I think this will be something really new for exploration companies. And it's the first time, and maybe Fernando can correct me if I'm wrong, but this mineral system thinking is incorporated in this whole exploration information system approach. Thank you.
Very good. Yeah, absolutely. And perhaps moving a little bit also on this geopolitical situation and potential risks that we have seen. Perhaps question for Fernando. With the mapping of critical new resources, and obviously there is a potential. How do you see? How do you see the solving of those new needs and new sources? Is there new deposits feasible to be found, or how do you see in the context of your project?
Well, it's not an easy question. I think one of the problems we have in Europe is that we love recycling information. And we see maps, generations of maps, they only change the colors, but they add very little new info. No? On one side, that makes sense because, I said before, Europe is quite explored, and if you find a new deposit, it comes out in the news. So, it's difficult, no? So I think in Europe we have to go to more to the greenfield exploration. At some stage, try to be brave enough to leave the classical areas where most of the mining companies are and trying to find new targets, new concepts, new methods of exploration. But honestly, again, I'm a bit skeptic that Europe can attain, as I said before, the self-supply, except for very, very few things. Unfortunately, I think that's the truth. And when you and myself, we have been working for a long time in this topic, in the very early projects, ProMine and so on, we thought, or we tried to convince the European Union that Europe had enough potential. When you see the results over the last years, you realize that very, very few mines have been opened, new mines. And again, I think we have to go outside, you know, and we have to be, or Europe has to be imaginative enough to try to secure the supply from, and compete, as I said this morning, with Russia and China that are not easy competitors, let's say.
Yeah, absolutely, very, very difficult scenario. And then, Mercedes, from your project, you have mentioned that, obviously you have these sites inland, also on shallow water, so that's something very peculiar. And considering all the context of the activities you do, also with Earth observation and other new advanced technologies, how do you see the challenges the project SR34I will tackle the
Okay, as I said before, I think that one of the strengths of our project is try to contribute in this aspect, and our project cover different pilots in different moments of the life of a mine, and therefore we can impact in different places and communities, always considering that actors involved in this kind of mine are able to use the information that we produce, okay? And through the new methods, through the artificial intelligence, we can improve this very nice map that we have from years, okay? And especially be able to offer this roadmap for every people interested in mining in different aspects.
Mm-hmm. Yeah, okay. Very good. Thank you so much. Also, Peter, I think that social aspects you commented is one of the key aspects of your project, of the BIT. From this perspective of your project, how those challenges are tackled?
Well, we have not only stakeholder engagement addressed in the project, but also social engagement. So social telling to the community engagements, and we shall organize various events, and we use various tools to engage the communities. To tackle this sometimes misunderstanding, sometimes normal communication with the local communities. So one of the tools could be doing some surveys. The other tool is to have on each test sites community consultation events, which is not always easy, but we think that to make them understand the project and the project goals and the eventual achievements of the project, we need communication with the local communities, and this is why we want to organize in the early stage of the project implementation these public communication events.
Absolutely, very, very needed. That's for sure. It is not only technology, social aspects, and how to engage with local communities is a key issue. So, yeah, perhaps we know we are running out of time because of the accumulated delay along the morning. But just would like to raise a last question for all of you, so you can answer any of you if you wish. Perhaps considering that, a little bit looking ahead, as a result of the different analysis, collaborative research, which are per se collaborative ecosystems, what changes or advancements do you hope that European mining industry will adopt in the near future? Starting from social aspects in this occasion, or any of you, I mean, if you wish.
I would love to come back to that point, that these collaborative R&D projects could facilitate what I mentioned is what is a gap between industrial uptake of new technologies, because during the implementation of these collaborative projects, industries can see what is done by the public research organizations, and public research organizations can also understand the needs, the real needs of the industry. So this could be a very good facilitator of this type of thinking together and doing things together, and uptake of the latest technologies by the sector.
Can I comment on that? I fully agree with you, and this has been also a question that I once calculated how many tens of millions or hundreds of millions of euros, I don't remember the figure, but it was a considerable number that European Union has invested in only on exploration projects. And the question is how these results of these projects are made visible for industrial organization and SMEs, and how come these results with public funded money are shown in the regions that are, we are having test areas in mining regions, and how these results are shown in the regions. Is there any new jobs for people, or are there any new SME companies established out of these results? What is the impact, actual impact, real impact, not the impact that is described in the proposal?
Yeah, absolutely right. Any other comment or perspective? No? Is there any other comment from the audience or from the remote people connected? All right. If not, yeah, I would like just to thanks once again to all our panelists, a very nice team, outstanding team. Also, all of you for your time and attendance, and for being patient, staying with us up to now. And yeah, I think that we have learned a lot from new things, new projects. I think that all panelists deserve a very big applause. Thank you so much.
Thank you. Thank you so much for your participation today in the session. So right now it's time for lunch. We have upstairs the lunch with a networking up to 3:30. Okay? So take your time to eat and talk. Thank you.
Sustainability clustering session of the European Raw Materials Clustering event. I hope you've had a good lunch, hopefully a convenient stroll or even a siesta, since you're here. I'm Ana Jorquera. I'm a project manager for the Iberian Sustainable Mining Cluster, and I'm going to facilitate this session, and then I'm going to be moderating the roundtable. Just as a reminder for the speakers, except the keynote speech, we have 8 minutes, okay? You will have a timer, in front of you. It is a good idea to stay within the timeline because then we have a very interesting debate and it would be nice to dedicate as much time as possible to that. So I think we will start with the keynote speech. Shervin Xavi will be doing this. I hope that I pronounced that correctly, but if not, you correct me now. I think not, from the face. He's a research fellow at the Department of Civil and Environmental Engineering, Faculty of Engineering of the prestigious Imperial College of London, and he's going to present the importance of circularity and sustainable technologies in raw materials.
Thank you so much. Is this my presentation?
Yes. You have a screen.
What's that, sorry?
You have a screen, so you don't have to.
Oh, okay. Okay. Thank you so much for the... I cannot see the text very...
Yeah, in the computer it was...
it's not that transparent.
Yeah, actually.
Then it's not clear that they change it.
Yeah, because they move, yeah.
Ah, they do it.
Yeah, yeah.
Okay.
Yeah, we have, sorry, tenemos otra diapositiva en la presentación aquí en el ordenador, pero no es la que vemos aquí arriba.
Thank you so much. Thanks. Great. Thanks. Okay, thanks for the introduction and thanks for attending this speech. I guess I started with a little bit introducing myself and then going through the presentation gradually. So, my name is Shervin Xavi and I'm a research fellow, Department of Civil and Environmental Engineering at Imperial College London. So we are a group of almost 20 people, researchers and PhD students, where we form the Resilience, Circularity and Sustainability Center. We do a number of wide spectrum of activities within our group, including technology innovation assessment, data analytics and acquisition, and digital transformation for smart systems. So from environmental assessment all the way through the AI machines and data transformation, etc. So people within different backgrounds, they does exist in the team. Well, our first objective is to advancing the circularity of raw material industries. Actually, we're going through a little bit focusing on the policies which can strengthen the sustainability in Europe based on the directives and acts that does exist. We are going a little bit through the EU sustainability goals, so to be sure that whatever we are addressing, they are based on the SDGs, and they are complying with that. And at the end, to also a little bit introducing the innovation for resource efficiency and transparency. So that will be going through the circularity and sustainability assessment. I'm going through the slides section by section. First, starting a little bit about what actually we heard in the morning regarding the higher level policies by EU, has been set a few years ago, and then continue all the way based on the defined calls and EU granted projects. Then I'm gonna going through a little bit through the innovations of the technologies we are developing within the group, and then we'll close the session by introducing a little bit of the future and prospective concepts and the activities that EU is calling for. Finalizing by the end of 2019 and been introducing by early 2020, we had the European Green Deal with the main aim of the net zero emission by 2050. So we are focusing a lot on the sustainable resource use. So it goes through all the way through the sustainability and the circularity, whatever we need to do that. And then gradually from that time, 2022 and 2023, we had the Circular Economy Action Plan, Critical Raw Materials and Zero Pollution Action Plan, which are then addressing the enhancing product durability, reusability, and minimizing waste. More relevant to the things that we are focusing here, we have the securing access to essential materials, again with the sustainable sourcing in the Critical Raw Materials Act. And with Zero Pollution Action Plan, we are focusing on the technologies that can reduce the pollution within the industry's activities that we have. But the main question still remains here, so how we assess the progress towards these action plans, how we can be sure that whatever we are doing here in EU, based on the projects and the demanding topics that we have, are actually providing us the way to approach the goals that we have here. Well, we know that regarding the raw material supply, it's been defined the national policies framework, which are focusing a lot on ensuring the stability of the resources and the materials that we have. And in order for that to be addressed, we need to have more stable transparency in decision-making and stakeholder involvement, and we need to actually have more effective resource management. So we see that on the figure on the left, that for EU we are more or less doing well in this regard, means that we are addressing the thing in terms of the transparency in the decision-making, we're stable to providing this, etc. There were a little bit of down things for some countries, mainly in the Scandinavia, including Finland and Sweden. But going through the figure on the right, then you can see that outside EU, so South America and East Asia, we would have some fluctuations, quite fluctuations here. So it means that if we can bring everything closer inside the EU, then we can address better what we are asking through the things here. The Circularity Action Plan, Critical Raw Materials, and Zero Pollution Action. We know that providing the enhancing transparency in decision making, we need to have a better data sharing and transparency. Like talking now in general frame, we need to provide whatever information that can be actually shared with publics. We need to provide that. We need to include stakeholders from different types of categories, like policymakers, from policymakers to ordinary citizens, different things, media, etc. We need to have good compliance with the regulatory oversight. We need to bring in the technological innovations like AI monitoring, etc. And then we need to actually address some sustainability certifications like ISO, the different steps of ISO in terms of life cycle assessment, life cycle social assessment, etc. But the main question here is then how we can address the requirements of EU Green Deal and national mineral policy through circularity and sustainability. What are the tools that we can provide that makes us closer for the decision-making system that at the same time provide us with a more sustainable and circularity assessment? Well, we have some key industries here, and through that we can provide, which can provide us with a lighter way to the technologies that we need to define. We know that at the moment and for future, a few of these industries will play a very key role, including the electronics and ICT, batteries and EVs and construction. So for each of these, you can see some numbers and data here, which means that they are producing each year more and more waste, and they are using some materials. But still, EU is asking for frameworks and for acts to be designed here. So it means that these industries are among those that are using a lot of our sources and producing a lot of waste in terms of emissions, whatever. But still, the sustainability and circularity is not well addressed here. So what we need to do is having a look into what EU demanding calls were during the last few years, and I bring in also some funded projects based on those. We see that, for example, building innovative value chains for raw materials, which Resila is focusing on, approaches to developing enhanced safety materials, Safe Loop project, recycling industrial waste, a water industry for I-waste, building water smart economy, water mining smart plants, streams, DigiTrace, etc. So we are looking and focusing on recycling and recovering materials, and also to do that in a transparent and sustainable way. I just going to provide you with a few examples here of the things that we are here. So in water mining project, we focus a little bit on ZLD, which is able to produce us with the reducing waste and improving the water recovery. But this needs still to be assessed through the Life Cycle Sustainability Assessment, LCSA. So we understand that, okay, we are now recovering things, but we should know that we are using the resources in an efficient way, and whatever emissions we have, they are not beyond the red lights that we have. Another example is about, again, the ZLD, this time focusing a little bit on recovering stuff from the seawater, where nanofiltration and multi-effect distillation was implied here. We could recover a little bit of water for the, also of the, a little bit of the other materials that we had here, which actually recover 95% of water recovery as well. We could also here recover sodium chloride and calcium sulfate. So it means that, again, okay, we are producing things, so the main target is being addressed, but the rest, which is also provide us with the energy and emissions, still is there. Another example with condensating recovery and treatment from a ceramic industry, it was in Sweden in the higher TRL levels, so we could actually increase a little bit of water recovery and reuse. So whatever stay here, again, sustainability assessment. Next was about using a little bit more advanced technologies like anaerobic MBR, Anamox, etc. here in Spain, which we, by applying ZLD, we could recover phosphorus and biogas actually. So this was actually a key point in our ZLD technologies. At the end, also in the United Kingdom, in the Cranfield wastewater treatment plant, we applied a kind of advanced water recovery and wastewater recovery, and we could actually recover here phosphate and nitrate. So how we assure that, yes, also for Resilex, that we are recovering silicon from end of life of PV modules and bring it back into the silicon production and sustainable eco-design solar cells. So here still, okay, the first thing is tick, we are recovering and we are recycling. But the question is how we can be sure that whatever we do is within the sustainable and circularity action. So talking again generally, there are some tools like MFA, LCA, circularity indicators, etc., which can produce with a good idea of how we can do this. But what we are doing in our group is actually mainly focusing here. So looking at the indicators for sustainability impacts for whatever technologies that I was just explaining you, we do all the assessment things there. So environmental impact, social impact, and economic impact. These can make us sure that whatever we do is sustainable from those three pillars of sustainability. So we're producing less emission. From social point of view, we are treating with people, workers, and the local people in a good way. And whatever we're producing makes sense points of the economic point of view. Looking at the broader measure and in the broader picture, circularity measurement and assessment is being assessed by addressing some of the circularity indicators by measuring the sustainability stuff. So looking here at, as a general thing, if you're doing, if you're assessing indicators for circular actions, for the flow measurements and for sustainability impacts, we can be sure that whatever technologies we are developing, they are based now on the circular action plan. Because we are recovering things, and at the moment we are not damaging our adjacent environment and people. Another thing of valorization we did here, so we sure, this can assure us that involved in Resilex project, we are recovering some materials, some metals like nickel, cadmium, etc. We are valorizing them based on economic evaluation and technical specification before sending them into the market. So we sure that can assure us that, again, we are treating the environment based of the sustainability things in a good way. Future tools, what EU now after passing through all these assessment stuff, what EU is asking for next round of projects and calls is that, okay, we are now implementing some prospective tools. For example, safe and sustainability by design framework is one of them. So this is another advanced tool. It says that, okay, you need to do LCA, social LCA, and LCC. But before doing all these, for whatever technology that you have, you should assure us that from safety and risk point of view, there is no hazardous things to the people and to the environment. So before letting us know that, okay, you are applying ZLD, you should let us know about all the materials and the chemicals that you are using. So be sure that they are set within the safe categories that we have. So you are not damaging people working on them, and you are not damaging environment. Once this is thick, okay, then you can go and do your LCA, social LCA, etc. You see that, okay, in order then to go through all these safe and sustainability by design, we do the material selection and safety, resource efficiency, end-of-life consideration. But as I said, toxic free circular economy is focusing a lot here. And then at the end, we're checking that the policy alignment and industry standard is being actually addressing here. So the new projects we have, maybe you saw them before, the Safe Loop and Streams, which are two battery actually related technologies. So we are recovering things from the cells of battery, and we're sending to partners to use it in anode and cathode active materials. We are using now safe and sustainability by design things. So to be sure that we are addressing what is needed here. Another thing is to be assured that, okay, we need to have whatever you are doing, you should assure us that the supply chain resilience, which means that you need to map the supply chain and whatever problem that might happen there. The risk assessment should be done here. You should have a supply chain diversification. So, okay, you say that at the moment I cannot have everything inside EU. I need to import things from South America or from China, but there should be alternatives here in the EU as well. So if geopolitical things happen, like a war or whatever pandemic here, you say that, okay, I have now resources in the EU that I can recover, metals or materials, whatever. So you should let us know that whatever you are providing us in terms of value chain, supply chain resilience. And then you should have good communication with all the suppliers and the stakeholders, and that you should also assure us that from sustainable point of view is compatible. Last but not least is also the climate change adaptation, also that we are focusing now on the understanding that whatever, okay, we are again providing you in terms of technology, we take into consideration the sustainable resource management. We are not taking the things out of the limits that we have. We are bringing it into the consideration that we are aware of the climate risk assessment, etc. So, for example, if adaptation or measures like avoiding floods, or I don't know, avoiding the surcharge of like sudden rain, whatever is, could be a probable danger, could be possible danger, we're providing measures for that. And then at the end, that the water management and water conservation is also being addressed. So to conclude, we are supporting EU circular and net zero goals. Okay, we are 3 different pillars of sustainability which should be addressed: economic, environmental, and social for each project and technology that we are developing. But we should at the same time enhancing the resource recovery and meets with the regulatory demands. And we should provide with a data transparency, so whatever could be, maybe a few of the data that we have could be also only be shared with specific types of stakeholders like policymakers, etc. But be sure that we provide as much as information that we have to the public, so they know that what we are doing. And then at the end, as I said, there are new framework and requirement that should be addressed, like safe and sustainable by design, climate resilience, supply chain resilience, etc. That's, I think, more or less wrap up the presentation. Here is the team. I appreciate a lot to helping me providing you this information. So Evina is our team leader, is a chair professor at Imperial College London, and then David and George, researcher like me and the group. But as I said, we are a number of 20 people in the group. Okay. Then thank you so much. Any questions?
Thank you so much. Yeah, you are super in time. Thank you. Okay, so the questions and answers we are going to reserve for the final part, for the debate. Okay, so this way we can speed up this part and then go on to this. Thank you. Leave this here. We actually have a pointer, so if any of you wants to use it, I'll give it to you now. So we will start right now with the project presentations. For the speakers, as you know, we have 8 minutes, so try to keep within time. And you have a timer over here, so you can have a reference for that, and you have your screen. So we are going to present first Juha Martti Kaija. He's a senior specialist of the Geological Survey of Finland, GTK. He's a geologist specializing in EUR projects related to mineral raw materials and their coordination for the past 20 years. He has managed several notable projects and is currently coordinating the Horizon Europe Islander Land Remediation Strategies project and the Undercover Deep Exploration project, which begins in January.
Yeah.
Okay. Additionally, he leads the stakeholder engagement work package for the EIS project, and he has been very instrumental in securing 93 million in funding for 20 EU proposals, where he served as key writer. So, go on, please introduce
Thank
us
you,
to
Anna,
Alexander.
for nice introduction.
Thank
Could
you.
where is this presentation
Yes,
here?
sorry.
Could you,
Forgot the important part.
yeah. Timer already started.
Here, stop the timer, please.
I lost 10 seconds.
Yeah. No, we'll get that. And now the template this is. Okay, let's start this way, and then when my colleague comes, we'll try to expand.
It's not there yet.
Just a minute.
Oh yeah, it's fine. While we are waiting, I can actually start a little bit. I will give you some highlights of the project Horizon Europe project Icelander, which is information-based strategies for land remediation. And it has a connection to raw materials related project because we have 2 test sites which are mining regions. One is Outokumpu in Finland and one region is in Kosovo with several spots there. Okay, now it's working. So I will start.
Thank you.
You can start the clock.
You can start the clock, yeah.
Yeah. So as I said, that this is a Horizon Europe funded project, and it's actually one of the soil emissions projects that we have funded in 2023. And we are focusing on promoting the delivery of Green Deal objectives, and in particular the zero pollution by reducing soil pollution. The key focus in Icelander is to facilitate soil remediation even when the cases are not or maybe economically marginal or negative. And we are trying to provide a more thorough understanding of the low input remediation approaches and a wider value proposition for investment cases and financial planning. It's a 3-year project and coordinated by GTK. Its budget is around 7 million euros. We have 15 partners from 13 countries and 712 person months. Here you can see the key objectives. The first one is to provide EUSO-compatible metadata catalog of all available soil pollution data. And EUSO means European Soil Observatory, which is operating under Joint Research Center. And it's actually the most important client for Icelander. Then there is implementation of sustainable and risk-based land management. We are proposing financial models to promote remediation actions, and then also proposing spatial planning models to prioritize and promote remediation action and reuse of land and soil. This is the team. We have a BRGM French geological survey, is another geological survey involved in this project. And then we have from Kosovo one partner, and you can see the rest of here. Few universities and research centers. And Finnish Environment Institute is also our valued partner. So this is a little bit background, and this figure actually shows the Icelandic project in the context of the major European instruments for soil health. And we are trying to contribute to policies which are related to soil strategy and to the proposed directive of soil monitoring, resilience, and other areas of policy where soils are crucial. And one important aspect of this project is to create an Icelandic roadmap that should help different stakeholders dealing with contaminated land to support expansion of the scale and pace of bringing challenging sites back into the productive and useful land use cycle, and avoid cradle-to-grave exploitation of soil resources and improve soil health. Here are the test areas. As I said, we have 2 mining areas as a test area. One is the Outokumpu copper, cobalt, zinc mining area in Finland, and Kosovo, where there are several hotspots related to organic contaminants, asbestos, mining and industrial sites. And then we have also, for example, areas from Sweden, France. The whole Toulouse metropolis area is one of the test areas. Then from Poland there is a Mazowieckie region where is this upland hop production, pesticides and creosides are the problem there. And former airbase, NATO airbase from Netherlands is also test area. This is the work package division, and I only show this because our clients, first one is the European Soil Observatory, and of course the EU level clients like DG Environment is our client, and then left behind regions, and we are trying to facilitate the economically marginal sites like Kosovo. And then we have also regulatory and policy interests at national level and regional level. Then those Icelandic test areas, they will provide data for development of these new methods, and they serve as test cases of knowledge-based strategies. Outokumpu mining region, well, this is a summary based on this manuscript, which has not yet been published. But we will start with this. There has been like 80 years of sulfide ore mining in Outokumpu, and that has resulted in significant environmental impacts. And at that time, the tailings areas, they completely lacked the bottom lining and consisted of highly permeable soil, and this led to early contamination of both groundwater and surface water by acid mine drainage. And also there were pollution of lakes, nearby lakes. And there has been, well, mine tailings areas has been covered, and there is a place which is partially landscaped into a golf course, but the cover is not sufficient to prevent ongoing sulfide oxidation. And these tailings have been also used extensively as a road construction material within the Outokumpu city center. And it's a small city, around 8,000 people living there now. And what are the remediation options for these lands? Well, disposal as a landfill. You can see the numbers there. It would cost like a huge amount of, largest cost would be, estimation is close to 300 million euros to remediate all these 50 kilometers of streets. So an Outokumpu city is really poor. It's a so-called left-behind area, so we cannot go for this. There's no funding for this. So another option is to establish so-called land use areas, as they have done in Freiberg in Germany. And they are areas that are classified according to contamination. And mostly in Freiberg areas are contaminated with arsenic. And there are different areas, and they are giving different recommendations, for example, what you can cultivate there and how much you have your own garden, how you can consume safely your products. And I think the last option is to disposing these road fillings into old mine tailings area and covering it with modern structures. So this is one possibility. But these are, and we are, of course, if you have good solutions for, and cheap solutions for remediation, we are open to your suggestions. Networking, of course, we are working with other soil mission projects. There's a list of them. And also EDAFOS project, which is the second one, they have also, I think they have also test site in Spain, but I don't recall what was that about. And as I said, we are open to collaboration with raw materials project facing similar challenges. And conclusions, we are contributing to policies related to soils, and actually all areas of policy where soils are crucial. And then, as I mentioned, this Iceland roadmap will assist different stakeholders to deal with the contaminated land and contaminated land management. And here is contact details. And now my time is up. Thank you very much.
Okay, so now our next speaker is Elena Robert. She's a specialist in gender development and globalization, gender studies, global studies, and international development. She is currently a researcher and project manager at La Palma Research Center.
Hi, everyone.
Okay, she's going to be presenting the CIRAM project. Go ahead.
Thank you very much, Anna, for the introduction. And well, everyone, hi, I'm Helena, as I was introduced, and I will be speaking on behalf of the CIRAM project on our team on La Palma Research, LPRC, based in the island of La Palma, in the Canary Islands, although we also have people moving around Europe all the time. So yeah, I guess it's a pleasure to be here because we are discussing quite a few complex things. And CIRAM, I would say, it's a quite complex project in itself. Differently from several projects we have heard about throughout the morning session, which are focused on developing a concrete technological or innovation sort of like output, CIRAM is dealing with the societal dimension of things, if you allow me to put it into brackets like this. We are coming from the need to balance, one, the resource extraction or the need for more critical raw materials sourced and extracted from European land, and two, the growing degree of environmental protection and environmental designation of areas that need to be preserved in Europe. Besides that, of course, we have all the actors that span across the conversation on these topics, and the ones that maybe are usually less included in decision-making, but still able to condition decision-making processes, such as NGOs or local groups and opinions. So coming from these kind of objectives and ideas, we are also aware that we need to develop capacity buildings and learning and knowledge transferring tools. So a bit in a nutshell, that's what we try to do and reconcile in CIRAM. Maybe a little bit like other projects have presented, I will briefly show you even if it's a little image, you will probably get the slides afterwards. The structure of our project, it's based into these 7 work packages, being the first one, the coordination and management, and the last one, the dissemination and the peer learning and capacity building kind of actions. The ones in the middle are actually what we need the most, and it's one, the case studies and the need to develop this mapping of best practice of what is happening in terms of extraction, exploration, and permitting in specifically some naturally protected areas in Europe, or mapping the occurrences of CRMs in or near these areas, and what could be considered for potential exploration and extraction. Then, of course, we have the stock taking of what are the policies, the regulations, the limitations and challenges in place at the EU, national, and regional, and sometimes even local scales that allow or don't allow for this permitting and for these operations. And also we have the sort of like appraisal of technological developments in Work Package 4, where we have to map the technologies as were presented in previous presentations that are being developed in the mining sector, in the extractive and exploration sectors, as well as in recycling procedures to transform and to process these minerals and these materials. We also have the Work Package 5, which I don't want to leave out of it because I think this is the crucial part of CIRAN and what we are enjoying but also struggling a little bit more with. This is getting in touch with local communities, having conversations with them on what are the challenges and what are the real needs for these CRMs for them, the real uses versus the real need to protect their natural landscape. And finally, we've got Work Package 5, which is about mapping all the policies, but also the recommendations on how to do things differently in our decision making. This is just an overview of our consortium, which you can also see it's quite widely spread across Europe, I would say, because of the importance of having these conversations in so many different cultural, historical contexts, and also especially linked to mining and CRM activity. And we also count with our network of experts, which I would say is also quite wide and international beyond European outreach, in order to have these conversations with people who are working on specific fields in their respective countries. I will skip this, but you can check the slides, especially if you would like to collaborate with us for like the community of practice conversations and events, but also for probably site visits and other guided visits. You will also be able to download all of this from our website, but I would say a little bit about the project results or work in progress results, if you allow me to, because the project is still lasting for another year and 2-3 months. So on the one hand, we've got the mapping of the good practice and the case studies, and this is actually partly thanks to our coordinators of this work package, GTK. So I'm happy to be preceded by them in this panel. And they were able to map the complexity of how some actual companies and industries are doing a good practice in terms of sustainability and in terms of CRM extraction and processing in Europe. So that is actually possible. But on the other hand, we have the conflicts between whether we actually need to extract those materials or whether we can reuse, recycle existing products with those materials instead of extracting. Following from that, I would like to also give some space to our scenarios, because that's one of the tasks that I've been mostly involved in, and I've been kind of dedicating a lot of mental effort to, because I would say it's kind of difficult to envision in the next 10 years how the whole landscape of CRM can look like for Europe, especially when you have so many contradictions between regulation and policymaking in different national levels. But in the end, we have come up with this kind of 4 ideal and not so ideal overviews of 2035 Europe with regards to more or less degree of CRM need, demand within Europe, and also the degree of technological development. And finally, in the last minute, I will address the external collaboration and the conclusions. I think part of the project is also about enjoying the, let's say, opportunities to go out there in the field and meet the people that are doing this in practice. And usually we take our opportunities of consortium meetings to go there and visit. In this case, it was in January in Lisbon, or well, near Lisbon in Portugal, and back this October in Italy, in Emilia-Romagna, where we were able to visit a couple of quarries which are active and where things are happening in a way that is in line with sustainability standards in the region, and where people are actually benefiting from this CRM extraction. So finally, we are faced with, I would say, these 5 dilemmas, but just to put it very briefly, first, what do we need these resources for? Where are we extracting them from, and how? Of course, who is making the decisions and who is left from these decisions? How close are we to the protected area in this case in order to allow or not allow extraction or processing? Then, of course, how sustainable are we if we are still allowing global trade from resources extracted from other countries? Finally, what type of growth and development models we need? and as well what type of citizenship we want for the future to make these decisions, if they are informed and educated enough, and if they are able to engage in the conversation. So yeah, I tried to be on time. You've got my contact and everything there, and look forward to your questions. Thank you.
Yes, you are. Thank you very much. Okay, so for our next speaker, we have Jura Janoko. He's a professor of geology at the Technical University of Košice, Tuke, and they are the coordinators of the WIDEX project, Jura and his team. And he's going to speak to us about the WIDEX project. Here you are.
Thank you, Anna. First, I would like to thank you for invitation to these nice meetings, nice sessions. I'm really glad I could come to Seville first time in my life. I'm going to talk about our fresh new project, WIDEX, which has started 5 months ago in June 2024. So we don't have many results so far, but anyway, during these 5 months, we did quite a lot of work, and I'm really satisfied with this. The project is from the Action Horizon Coordination and Support Actions, CSA type, and so this is not the project like the others which were referred here from the type of excellent research. But I have to be very fair to say that this is the project which really can help our university, our technical university of Košice in Slovakia, because we are not very experienced with leading such projects, and I think that the first step is quite fair to get this CSA action project, and then we hope that we can succeed with the external research projects. The Technical University of Košice is an old university, and it has 7 faculties. One of them is Faculty of Mining, Ecology, Process Control, and Geotechnologies, and this is actually the only one faculty for mining in Slovakia. In spite of this, and even if we are quite active, especially in the EIT raw materials organization, we don't have many horizon projects. I'm showing here that this project is Horizon Lump Sum Grant, and I know that everybody knows here what is it, but it is something very new for our people at our university, for our economists, so this is also a kind of contribution of this project to our university. What is the project background? So the background is, of course, the increasing demand for critical minerals and elements, to secure access to critical and strategic raw materials, advanced materials, and processing know-how, and also the mineral resources in Slovakia. Slovakia is a country with great history in the mining. Actually, we have several mines open now or active now, but we have closed many mines in the past, and we have closed them because of one factor is that we close them because of not good technologies, and we hope that the new technologies and innovative technologies will help us to reopen these mines. And another background is that TUKE, Technical University of Košice, is a very distinguished player in the raw materials field in Slovakia, but we still need to be even better. Everybody wants to be better, but yeah, we really would like to improve ourselves. The main aim of the project is to transfer to TUKE the necessary knowledge to build capacities for innovative exploitation methods and to adapt novel clean technologies for exploration and processing, as well as augmenting virtual reality on exploitation sites. We have 3 key objectives. First is carrying out the knowledge transfer necessary to broaden TUC expertise in green technologies and methodologies for exploration, recovery of CRM, and restoration of critical raw materials mining sites. The second one is strengthening TUC's capacities to drive sustainability, circularity, and social assessment. And the third one is to support TUC's research management, coordination capacities, and administrative skills, and to visibility and attractiveness with activities for knowledge transfer of key aspects. Well, here we have the structure of our work packages. We have 9 work packages. And what is quite important to show that work package 3 is the knowledge transfer in the area of green and non-invasive technology. It concerns mostly of exploration and processing. Then the work package 4 is knowledge transfer in the area of sustainability, circularity, social assessment. And work package 5 is knowledge transfer in the area of research management, coordination, and administrative skills. Then what is the most important for our university is work package 6 and 7, training and education. So we get the trainings from different participants of the project, and this is the main activity what is really very worthy for the university. And the last work package 8 and 9 are dissemination and establishment of an industrial cluster. What is very nice in this project that we have a good structure of the project. There are 11 partners from 7 countries, and there are partners from the academic field, there are partners from research field, and from the industry. So that's really very good. I can see now that when we have started the education of our young scientists, there are many experts from industry who can really contribute to increased knowledge of our young scientists. This is this is what we really appreciate. So as I said, the main aim is to improve our knowledge in the exploration and processing field, also in the field of restoration and rehabilitation. In the rehabilitation and restoration, we will also be learned by virtual reality, which is really something very new for our workers at the university. Collaboration and networking. So we collaborate with many projects at many institutions, but I show here that we would like to collaborate with any institutions who work in the exploration, mining, and processing. Yeah, maybe I would stop my presentation here. Thank you for your attention, but maybe at the end I would like to say or emphasize really the importance of such projects for our university. I would like to say that I worked several years in the faculty management, and I tried to improve the quality of our faculty of mining. But this is very difficult. It's like, to turn a big vessel in the sea. So if you turn the vessel, you need 2 kilometers more to turn this vessel. And the same is with the faculty. I could not manage to turn the people at the faculty. But now when we got this project, they are really forced to work, and they gradually can see the sense of such new work and the better perspective for them. So this is really very good, a good thing. Thank you.
Thank you. Thank you, Juha. Okay, so we are going to make a slight change because Daniel Morford is going in between sessions. We are going to see now the Futuram project with Daniel Montfort, whom is an engineer of circular economy and mineral resources and head of projects at BRGM.
Yeah, thank you. Good afternoon, and thank you for inviting me to this event. So I was in the other session presenting another project. So maybe I won't be there in the round table after that. So I think that if there are one question, maybe I can take it now. Well, I will present to you this project, which is called Futuram. So Futuram is future availability of secondary raw materials, and it is a continuation of previous projects where we in geological surveys in Europe and other institutions we participate. It is the continuation of a previous project called PROSUM and also a still previous project called PROMINE. So, in very shortly, we call it Futuram Conceptual Framework. That's Futuram House. So, first of all, we are working with different waste streams: construction and demolition, mining waste, slags and ashes, electrical waste, e-waste, batteries, and vehicles. As this waste represents waste flows and flows, that means that it is dynamic. Well, with the exception of mining waste of historical legacy sites, that's a little bit different, but we are buying new products, we are demolishing every year new old buildings, etc. So it is dynamic, so we need this, to assess it through the dynamic modeling and considering future stocks, future flows, etc. So, and this is a combination of the composition of this waste. So we need to assess the composition of this waste, and we are looking to critical raw materials. So we need to assess the content of copper, the content of nickel, the content of cobalt of batteries, or the content of neodymium for magnets, for example. And at the end, we are multiplying, let's say it, with future stocks and future flows. And that's the future availability of secondary raw materials. But availability does not mean recoverability and re-availability. In the middle, we need something which is called recycling or refining, our metallurgy. So, so we are trying to assess also which is the real part of those metals, of those critical raw materials contained in alloys, batteries, etc., that are really going to a recoverability process and with success and not downcycling, real recycling. And for sure, we are trying to model the future because, as I said, waste are dynamic, so we need scenarios. So we need to what if we continue with business as usual thing, or what if we are more circular, or what if we succeed with critical raw materials targets. And that's also questions that we are covering. And also we are using the United Nations framework classification system for minerals and raw materials. Very shortly, we are a big partnership with 28 partners from 11 countries. We have a contribution of Horizon Europe program plus UK and Swiss research agencies, and it's a 4-year project. As I said, we have 7 waste streams, 6 plus 1 because we include at the end wind turbine. Wind turbine, that it is a quite particular waste stream. We don't know if it is construction and demolition or So, well, at the end we created a new one, and wind turbines are typically a case study which is a little bit complicated. I will share with you several results, please. It's preliminary, still not published. It's just an overview of what we can imagine that Futuram will provide you at the end of the project. So, for example, that's an example. We are calculating with this modeling the stock and flows and end of life of all the wind turbines in Europe. We are modeling how many critical raw materials, so for example here boron, dysprosium and neodymium, it is contained in wind turbines wasted in Germany, in our country. And for sure, right now, we are not demolishing wind turbines, we are mostly installing new parks every year, so there is no neodymium, no dysprosium that it is wasted from wind parks. But with the families of wind turbines that were installed maybe in the 90s or maybe in the beginning of 2000s, in maybe 10 years will start to be decommissioned. Not entirely, but a certain quantity. And consequently, not all the parts contain permanent magnets, but some parts contain permanent magnets. So we can imagine a certain amount of neodymium and dysprosium, but it is in the order of 100. That's very, very low. Huh? So that's also, the goal of our project also is to size the real contribution of the urban mine to the objectives of, for example, of Europe. So we can also consider this figure and say, okay, but we need mines to achieve this objective. But because, and this example is a very good example because we need wind parks for carbon transition, low carbon economy transition. So, so we need more magnets, so we need more rare earths. And Critical Raw Materials Act is saying that we need more rare earths that are not coming from one single country. Same type of results in other products, so for example here batteries. So that's an example in the UK with the quantity of critical raw materials, cobalt, lithium, manganese and nickel in waste batteries generated every year. And that's, it's now here is a bigger volume of waste compared to magnets. We can also imagine to restitute information in this type of plots about, yeah, which is also the presence of cobalt in different types of batteries, for example. For mining waste it's a quite particular waste, and mining waste we are mostly looking for historical legacy sites, historical mining waste. And that's an information that typically geological surveys we maintain in national databases, and it is also an objective of one article in Critical Raw Materials Act that, each member state of the Union must maintain and update a mining waste database. Here it is an example of Sweden from colleagues from Geological Survey of Sweden with the maximum average value in Swedish tailings. So for sure, Sweden have a historical tradition of exploitation of apatite and iron. So iron and titanium are important here, and that's a way how we can also restitute this information. Mining waste is also something that we can map. We can produce a map with dots with different mining waste sites in a country and different content. I have no more time, but we are also producing this type of foresight, including also what is happening with collection. For example, here in electronic waste, we are working on a portal that's responsibility of BerGM, and yeah, that's all. Gracias. I must be in the other round table.
Yes, go on. Thank you, Danny.
I'm still there later.
Okay, so for our next speaker, we are going to invite to the stand Marcello Colledani. He is a full professor at the Department of Mechanical Engineering from the Politecnico di Milano, and he is going to present the project BATMAS.
Thank you. Good afternoon from my side, and thanks for the kind invitation to this event. My name is Marcello Colledani, and I'm the coordinator of BATMAS project. So I will give you a brief overview of what we are doing in this project, and hopefully about the opportunities for cooperation and for exchange of information with this project. I know it has been a long day for all of you. I mean, I was in another meeting, project meeting, in another site in Seville, so also for me. So I will try to make it a little bit lean, this presentation, also because it's the first time I present this project today, so I try to be informative but agile as well. So first question that I would like to raise, who is aware or involved somehow in the I3 program of the Commission? Because I'm seeing, okay, so there is some experience in the room, good. I've seen Horizon Europe projects. I've seen also, well, different type of projects, CSAs or innovation actions. This is a project that has been funded in the I3 program. I3 stands for Interregional Innovation Investments. So it's a relatively new program. It has 3 years now of the Commission that tries to foster high TRL projects that are elaborating upon results achieved in other previously done projects or industrial initiatives at local level, and exploiting the cross-regional cooperation for favoring companies' investments in an innovation environment. I will be hopefully a little bit more clear in the next slides. The topic of our BATMAS project, that is the largest being funded in the I3 so far, is written here. So we are trying to establishing and demonstrating a circular battery valley in Europe. So trying to validate the feasibility of industrial pilots along the circular value chain of batteries. What is the motivation? What is the challenge? So you know very well that with the ongoing transition to e-mobility, but also with the growing demand from stationary applications, batteries are becoming very important components. Also from the same previous presentation we have heard about this. And of course, although the discussion is still ongoing on how fast should this transition to e-mobility being taking place in Europe, the future is somehow kind of clear for this market, and automotive, as you know, is the largest market in Europe, so it's an important transition. Volume of batteries is increasing, although so far not as expected, but the price is going down, so most probably the growth rates that were expected will be respected in the future. We hear this many times, so people saying, well, but the problem is what happens to batteries after the use phase. Actually, in Europe, there is already capacity installed for recycling batteries. There are 80,000 tons per year of recycling capacity in Europe, but this is already saturated. So this is saturated because of the flows coming from other sectors as well, electronics, upon all the others. And this calls for needs of investments towards the opening of new plants, new facilities that may, on the one hand, intercept the end-of-life batteries, on the other hand, grasp this business opportunity. The chart on the right shows that the introduction of secondary materials in battery production will bring benefits, especially for some chemistries, to recycling companies in the future with non-negligible market potentials. Of course, this is the big challenge, trying to make the quality of the secondary streams comparable, hopefully with the same specifications, of the primary streams in order to mix those streams and ensure, on the one hand, the availability of materials that can support this quick uptake of batteries in Europe. On the other hand, try to make secondary materials available in order to ensure that European manufacturers of batteries, you see here 25 gigafactories that are predicted in Europe by 2025, maybe later, but still in the pipeline, will be able to meet the minimum requirements that are reported in the battery regulation that is already out that will be applied by starting February 2027, which is basically tomorrow. So this is the whole objective of BATMAS. And I will give you a hint on the 3 pillars: interregional, innovation, investments. So why are we interregional? Well, as most of the projects, we have partners from different areas of Europe. But interregional also means that we are trying to elaborate upon the smart specializations of the different regions of the partners that are in the project. This has to be very clearly explained why you submit an I3 project, how what you are developing meets the outcomes or the strategic plans of the regions where the companies or RTOs that are embedded in the project are part of. And as you see here, we have partners also from this region, and thanks for the invitation by the ISMC for the organization inviting this project here, but also CTA is part of the team, so actually from this region, CTA. And we have other collaboration with other regions worldwide. You see the partners here. The second pillar is innovation. So as I said, we are grounding on the results of other projects. You see here some, DigiPrime, very well linked with the project that was previously presented on the digital platform. Batro and Respect, that are Horizon Europe and Horizon 2020 projects, but also on the technical capabilities or the RTOs that are in the consortium. So here you see an example of what has been established in Lombardy with the money from the region that are very recent action for enhancing the capability of the RTOs to support companies in this transition. And by elaborating upon these results, we are establishing and demonstrating pilots all along different steps of the circular value chain. So now we go to the innovation dimension. I will briefly show you the 4/5 pilots that we have, because in Second Life we have 2 pilots. The first one, it starts from the transportation of post-use batteries. So we have a ERP that is one of the consortium for batteries in Europe, European Recycling Platform, that is developing a new container for transporting batteries and measuring the conditions of the post-use batteries before they are actually treated by these assemblers and dismantlers. The second pilot is more focused on second life options, so trying to reuse modules and cells when possible into stationary applications. 2 companies here, Envirobat and Green Vision. Envirobat is actually from Spain, from close to Madrid. And then we have a third pilot on recycling by Orano from France. They are installing a facility for doing mechanical pretreatment and hydrometallurgical processing for obtaining pre-CAM and CAM. CAM stands for cathode active materials. And the final pilot from Verkor, that is a company producing batteries, one of the 25 gigafactories, that is demonstrating the feasibility of reinserting these battery materials into new batteries by mixing with the virgin fractions. So really closed loop recycling is the objective. We are in the middle of the project, so I cannot provide you concrete measures, but the outcome will be very easy to test. If we prove the feasibility of this circular value chain, then we'll be successful. If these batteries will not function as they should, then we'll be failing. Very, very clear and easy to measure. We have an initiative to involve and cooperate with the external stakeholders, and it's called the Circular Battery Valley. I don't have time to give you the detail, but please go to the website BATMAS, and you will see how to get interacting with the project. And by now, I will thank you very much for your attention, and of course, available for questions and further discussions. Thanks a lot.
Thank you so much, Marcelo. Okay, so now for our last speaker, we have Diego Morillo Martin. He's an area manager in the functional materials and processing, and he's going to present the project Romina. Thank you, Diego.
Thank you for the invitation, and thank you all for being here. I'm Diego Morillo. I'm area manager in functional materials processing in Leitat Technological Center. I'm the scientific coordinator of Romina project. I want to give you a brief overview of Leitat. Leitat is a technological center based in Barcelona, in Spain. It was established in 1906 due to the textile sector in Spain. And focused in raw materials, we work in different stages of the value chain, from the starting material through the selection of the different materials that can be valorized, the pretreatment, hydrometallurgy, and selective recovery. My team is working on membrane technologies development. And the main goal of Leitat is generate and transfer technology to companies or to the industry. Romina project is a Horizon 2020 project with the aim to develop and demonstrate a pilot system, integrated pilot system. We have different key objectives. The first one is the industrialization in a high scale and flexible way for the valorization of the mine wastes in a continuous mode. We have different KPIs related to the recovery of CRMs, mainly cobalt, antimony, germanium, and tungsten, the recovery of the iron-based byproducts, and the recovery of other toxic and non-toxic metals. Also, we want to evaluate the alkaline leaching to transform part of the gangue generated in the process to recover precious metals. At the end of the project, we want to treat around 150 kilograms per day of mine waste. I go to show you later. And we want to transform a little bit the way of the linear model of the mining sector today by a circular model where the mine waste is a resource. The Romina project was founded in May of 2021. We have 28 months. We are now in 42 months, so we have only 6 months left till the end of the project. We are 19 partners from 10 different countries. The process is a little bit complicated, but I go to show you fast. We have different stages of the process. Selection and pretreatment of the mine waste selected, bio-leaching process where we beneficiate most of the metals from the waste, iron removal process where we take out most of the iron we have in the leachate, and a selective process for the recovery of the different metals using membranes. So as I commented, we are in month 42, very close to the end. So we have been working in the optimization and the scaling of the technologies, the validation, and the engineering, also together with the sustainability assessment and social innovation, the exploitation, communication, and the management. So some results during the project. We selected 3 different mine wastes. 2 of them are close to here in Cobre Las Cruces and Tharsis Mining. The other one is placed in Portugal. We have been working in the bio-leaching to remove or to beneficiate the metals. In this case, we were at lab scale. We were able to beneficiate all the cobalt and most of the antimony, and through alkaline leaching, we were able to beneficiate most of the tungsten. In case of the iron removal, due to the new technology we have developed, we are able to recover at the lab scale the 90% of the iron, and we developed the membranes based on nanofiber membranes for the selective recovery of the metals. After the first step at lab scale, we constructed bench scale pilot systems we constructed the bioleaching and alkaline leaching, the iron removal, the selective recovery of CRMs through membranes, also an electrowinning process, this is a mistake, to electrodeposit the metals and also the electrocoagulation system. So with this testing, we were able to generate data to be transferred to the engineering part. And this is really new information. During the summer, the last 3 months, we have been operating the pilot system. This is the pilot system we have installed in Cobre Las Cruces. Okay, you can see here in the image 1, 2, 3, and 4 bioleaching tanks of 4 cubic meters each. And here you can see the belt filter where we precipitate the iron during the process. So now we can see that we were able to construct the pilot. The preliminary results, we observed that we were able to precipitate most of the iron and the cobalt and part of the antimony. The rest of the antimony we are able to precipitate by alkaline leaching. Also, we evaluated the capacity to make the cyanization of the gold. And during the precipitation, we can precipitate most of the iron. So this is the team, coordination team, communication and exploitation team. And as a summary of the presentation, during the project at the very beginning, we were able to upscale the technologies and validate them to strengthen the integration in the future steps. We were able to make the engineering of the pilot system together with an intelligent management system. We have been working on the sustainability and risk assessment in order to evaluate the exposure scenarios of the people. The preliminary, we have done preliminary work in the pilot, getting good results with 2 different mine wastes. And now we have been evaluating the exploitable results. We have identified 20 exploitable results with 3 patents filed in the last months. And thank you for your attention.
Thank you so much. Okay, so now we are going to start with the roundtable. So I would ask the speakers to please come to the front. Yes, Juha, Jurat, Helena, Daniel Monfort is not going to be present. But then we have Diego Morillo, Marcelo Coledani, and Servin. Yes. So to start the roundtable, I think it is interesting. Okay, thank you, Alicia. To start the roundtable, I think it is interesting to let the public and let you amongst yourselves now make those questions that maybe weren't made during the presentations. So does anybody have a question that they would like to address to them? Or do you have questions about your presentations or your project? Okay. Yes, probably. So yeah, I have some questions. Hopefully they will raise some kind of debate and conversation, not so one-sided. But so I have a question for Juha. Have you already been cooperating with other mining regions facing similar issues as the ones that you are facing at Outokumpu?
No, not yet, because in my presentation I told that we have 2 regions, mining regions, Outokumpu and then Kosovo region with several hotspots. But of course we are seeking for cooperation with other projects with the same kind of remediation problems or challenges. And I have already conducted at the Mining and Minerals Hall yesterday. I had several discussions with some projects about this cooperation, because I think the cooperation is the key. Icelanders soil emission process, but it has so much in common with mineral raw materials process and remediation issues. So, and we should openly exchange information to be better in our work.
Okay, thank you. But you have identified, you do have regions identified where you would, you have possible collaborations with similar situations.
Actually, it's kind of easy because I'm involved in maybe too many EU-funded projects, so I already know those Spanish regions and regions from Portugal and also from Greece. So
that's great. So that's something to explore.
Yeah, and I'm like networking in my head. So.
Okay, thank you. My next question is for Yura. So you were talking about this before, and you said maybe that you wanted to, if you had the occasion to go further into this. What has WIDEC as a project provided to, or is providing, or is going to provide, because it's still at very initial stages, but what is it providing to the university? You were talking about that, about it making the researchers and such to face several subjects or some innovation that maybe they weren't facing before?
Yes, as I said, for the university, as our university, it's very important for people, especially for young people, to communicate and to meet each other. This is really very important. And I feel that there is still not enough meetings and communications between these young people, both in Slovakia and internationally. So now this WIDEC project brings opportunity for these young people to communicate with colleagues abroad and to hear new ideas and new methodologies and techniques for, let's say, exploration or processing. And this is something what is really very good for them.
And what do you think, what kind of exploration technologies, maybe some of the ones that you are going to see within the project, or maybe some others, what kind of exploration technologies do you think are going to be at the top during the following years, like the best or the most sustainable, actually?
Yeah. Actually, we could hear it in this morning, in this session. I think that what is really on the top of our agenda is artificial intelligence, machine learning, because at least in our country, and I guess in all post-communistic countries, what we have, because of very good financing of exploration in the past, during the socialisms, we have a lot of data, but these data are not were not very well interpreted, and then they were not very well synthesized altogether. So now what we need is, but they are of high quality. So we have different quality data from different sources, and now we need to give them, to fuse them. Yeah. Okay. And this is what probably the machine learning can help us. I think that interdisciplinary approach and the multi-source of data really helps to this, but we need to teach the computer what is the best data of them, what are reliable data, and then to use them for the exploration.
Thank you. I see a lot of faces saying yes. So does anyone else want to comment on this, on what Jura was saying about the importance of artificial intelligence in the future?
Well, within our team, it's not me who are doing the artificial intelligence things, artificial intelligence stuff. There are other people working with that. But I would say, yes, the exploitation can be done in a number of things, like from very simple thing of like distributing some, I don't know, even newspaper or catalog stuff for people who are interested in your project, and even to have sessions, make, I don't know, roundtables, to make kind of conferences, workshop, etc. But from the thing that you were explaining, the knowledge transfer, because I do or I'm trying to do a knowledge transfer thing in one of the projects I'm involved in, Resilex projects. And then I'm following actually a model which has been developed through the years. They call it the quantable helix model. So it started with triple helix model, going to quadruple helix model, and nowadays it named quantable helix model, which then it has first started with 3 pillars of actors, going through 4, and now it's 5. So it's simply saying that, okay, once introducing a solution or a problem into your society, which can be everything, policymakers, university, anything, you bring in the problem and then introduce a solution from your academia, and then it starts circulating that knowledge from a know-how on solutions, so in a structured way, through all the actors here, which could be people from academia, from small startups, going then to industry, going to citizen, going to policymaker, etc. So people, actors in this round from either of these 5 different helices, they can say the solutions that they have based on the know-how of the people previously being seated there. So for example, if I say that I want to recover silicon, for example, I might have a solution from a experimental or lab scale thing, but that needs going through the high level stuff. And the main goal is that, okay, the policymakers, they pay more attention to the companies inside EU rather than just importing stuff from China, wherever, just because they are cheaper than the things that we have here. So I can introduce that. Then I can talk with startups, with smaller companies, industry, so we can raise a little bit the TRLs that we have. And then that can also be shared through the newspaper, media, whatever that we have with citizens. And then once gathering everything here, we can now go to policymakers and tell, okay, now we have these solutions. We are targeting like to recover these types of metals, materials, whatever. And now we have solutions from academia, from industry, from whatever. So it makes sense from all those things. Now you can make a new act or a new rule or a new taxation system. You can reduce less, you can reduce the imports, and you can rely more on the things here. So yes, this know-how thing can be done in a structured way of modeling where people of different types of stakeholders are involved. They know the solutions that already does exist in the circle, and then they can have their own system of the solutions or whatever. So yes, that was what I was thinking. I'm doing that in Resilex now. I made a questionnaire. It's not an easygoing questionnaire to work because it seems a little bit of, there is science behind that, and there is innovation pillar, sustainability pillar, people working on it, but I think it would work at the end. Yes, and then there are tools, for example, with artificial intelligence that can then predict that based off the scenarios that we have, what is the best solution to follow in like 10 years time from now. So from all those solutions that we have now, we can score it and weight it in the system, like in fuzzy cognitive system, to see that, okay, in 10 years time from now on, which of the solutions would work better? Will putting taxation on Chinese import, like investment on the EU small companies, or put more money on R&D sector, etc., etc. So yes, these kind of things can be done to have it in a more broader and comprehensive way. So yes.
Thank you. Yes, of course. Can you?
Thank you. I think because the point on data also came into the conversation, dealing with case studies and best practice kind of tasks. This was in the CIRAN project, not my or our task as LPRC, but GTK's, but sharing within the consortium the struggles and the challenges that they face. Actually, it becomes clear that sometimes there is a lot of data available, but it's not so available to those that do not directly work in the Geological Survey, for example, or in the national agencies. And also maybe it is not sometimes so well structured, meaning that the data is there, but it's not easy to work with, and it's not so like easy to just get it and get results from it. So this was like kind of the reflection that we made. Okay, that's why we need this kind of events, that's why you need to go to visit the mines, the quarries, and the industry, also sometimes in person, because establishing these personal networks and this physical contact allows you to, in future projects and in other long-term plans, have a more like trustworthy and like kind of like, yeah, trust relationship to use their data for a scientific and research purpose. Also, on that sense, I think sometimes you have to be careful if you have the data, because we are talking particularly in terms of sustainability. Maybe you don't want it to be known that there is such a good amount of like a certain mineral or certain critical material there, because that would mean that any kind of like actor could come and, you know, try to set up a company or an exploration or exploitation activity there. So you have to follow the necessary steps to make sure that whoever has access to that data and wants to use it has this circular and sustainability approach to it besides research. So, yeah.
Small comment on that, because this is also a question about what about those EU-funded projects that are delivering a lot of reports and a lot of good information. Most of them are public. Like in mining and metallurgy regions of European Union, Mireo project, there are a lot of good reports regarding the social license to operate, social license issues, and also the funding mechanisms. But of course, the people who have been working with the Mireo project, they know about them. But do you know about this? And how this information would be more, you know, more available? It's public, but how to advertise this information? That was my question.
Yes, that was actually something that came to mind to me too. Like, there's a data, it might be available, but do we know it exists? Do we even know that this data might be available or not available, but exists? So I find that interesting. Yeah.
In Romina project, we are collaborating with RMIS, providing a lot of data. First, coming from the characterization of the mine wastes, but also with information about the bioleaching parameters, the results of the extraction, and these things. Most of the data are public because we share with them. But what you say, most of the people doesn't know that this information exists in the databases.
Thank you. That was interesting. Okay. Yeah. Okay, we have a question there. Okay. Just a minute for the, yeah, but we have the online people, so let's wait just a minute.
Yeah, I just had a question if the data is available, but we are looking for a lot of data and we are not publicly finding them. You have your deliverables of European projects, but the data as such, which were analyzed or as a result of the project, it's not always that easy to find. So yeah, I know that the Commission has a website and they put everything there, but in the end, the actual data I'm, for instance, looking for, I can't find. So there's still a bit of work to do there, is my opinion, but I wanted to hear the feedback.
Is the problem, it's just curiosity, is the problem not finding the data or not having access to the data?
I think it starts with not finding them, but for instance, I found a big database, but there's then no data in there. There's a lot of links and a lot of information, it seems, but actually finding whatever I'm looking for is then a problem. So yeah, I'm not sure if you have an answer, but...
And if you look information from Cordis, you can find, but then you have to search by project, and there's no good search engine at the Commission. So this is where I think that the artificial intelligence should be doing something.
Okay, but
do you have any suggestions as how to tackle this, or?
Yeah, for one of my ideas would be that you, instead of, we all produce reports which contain also quite a lot of data, but that the data that are already in those reports are in another way structured or being made available so that it's easier to search instead of going all the reports, through all the reports or all the publications that are made in a project. So that would be a suggestion, but I don't know whether that's the full solution, but it would be a start that we just have, data in a format that is accessible for all of us. I don't have a suggestion of which source, but that it's not in reports or in papers.
Well, there is some tools, I think, like the raw materials information system and such. I'm not sure if the data included there is not the one you might be looking for, or if it's not in the adequate format. Have you, I imagine you have access this to look at it.
No, I don't know what you mentioned.
The raw materials information system?
I'm not actually really familiar with this system. Okay. It is supposed to compile all the information related to raw materials project, but I don't know if it's good enough to find information.
So it contains a lot of information right now. I'm not sure if it would be like the information, the data, the raw data that I think she's looking for. Okay.
Well, on this point of data, I think that even if there was a system or a tool for exporting data, without the semantics, the data won't be useful anyway. I mean, consider data about what? Data about the input situation, the starting situation of a project. That's data that we are collecting from sources. But data that are interesting are those that are produced with the foreground of the project. And in order to be made useful, they should be contextualized and they should be added with the semantics of the data that then could be, let's say, made available externally together with the instance, the real number, right? Without the but building the semantics takes time. I mean, of course, we know it. It takes time and there is a project per se. So, in my view, this issue is probably 15 years that we hear about this idea of sharing data that is coming from projects. There are some progresses because there are at least these tools that make it possible to share some data that could be shared, but it's intrinsically complex. If you don't invest in creating a semantics and making it possible for the external stakeholders to understand what they are downloading, who are downloading a number, then it's hardly solvable, I guess. So this is at least my perspective on the problem.
Okay, thank you. Does anyone else want to comment from the public? I think. Okay, so I want to skip to another speaker, Elena. So here. If you want. What are the main challenges related to obtaining social acceptance through policymaking? You spoke a lot about social acceptance and such, and I'm interested to know the challenges that you've found.
Yeah, actually, thank you very much for this question, because coming from this whole conversation, I was thinking about bringing up this topic, because of course we didn't have so much time to go into the details of all our projects. But one big part of CIRAN, besides the policy-making frameworks and regulatory frameworks tasks, is dealing with how to adequately and carefully approach local communities and talk patiently about these topics to better understand the narratives in each location. There are several, I would say, historical, cultural relations in every community, in every country, but even in every region within every country. I'm sure in Spain you will find different associations to the idea of mining, to the idea of extraction, to the idea of minerals in general as an industry, but also to manufacturing and to the whole industrial sector. And those, I think, need to be kind of like tackled case by case. So to give you an example about the actual challenges, in Siran we are engaging with 5 communities that we selected after a first search of looking for, of course, linked with our consortium so that we could address communities where our consortium partners would be based, but also other communities outside of the consortium, because the condition was that those regions didn't have any active site or any recent mining activity ongoing at the moment where the Syrian activities were to take place. And that was in order to explore the conversation of what would happen if these kind of activities would happen in your territory where you actually have a protected area, naturally protected area, zone, Natura 2000, UNESCO site, whatever in your surroundings. And that means the first year of the project in Work Package 5, which is the one dedicated to community engagement, was only and mostly about developing a full methodology, exploring the narratives present in the communities in the past years and decades through social media and through traditional media narratives, but also while doing some literature search. And then from there, starting to plan the actual events, like the actual going into the place, negotiating with the municipalities about organizing this event to talk about this here, and then gathering the group of people, contacting them and talking about the issue. So 1.5 years afterwards, we have had the 4 focus groups and we still have 1 more focus group to go. And we've only had 1 public discussion, which is fine because we still have another year to do the other 4. But that means time, basically. So just to wrap it up, I think technological projects can go fast. They can take, 3 years, 4 years, and you can have prototypes, testing, and so on. But projects which have a societal conversation and dialogue component need more time to have these conversations carefully and adequately.
So how would you tackle this on the long term? Because we have short projects, very intense projects where we are testing something, we have pilots and such. How do we approach this? Because once you are starting maybe to increase this social acceptance, then the project is finished and we go elsewhere to tell, or not, or we stay. But sometimes we finish the project and we go elsewhere to keep on testing.
Yeah, and also because you might get the funding for somewhere else, for some other type of consortium and composition of geographical composition. So I think also just to be brief, because I want others to jump in, but there are 2 key things that I would like to emphasize here. First, of course, the short-term element of the EU-funded projects means that while you are in the project, you need to keep thinking of, forward thinking, what's the next steps that we can take to continue this being funded, and ideally in this same location so that we can ensure the continuity of the communications that we have established in the past 3 years. And second would be, I actually forgot, remind me of it. Oh, yeah, sorry, the political cycles. And, politics being brought up, it's not the main issue maybe in these conversations, but actually it has come up in the previous panel. And the fact that in Europe we have such a strong, I would say, compared to other regions of the world, democratic structure means that things change regularly as public opinion change and voting opinions change. And therefore you need to kind of balance these 2, coming together in this type of events to keep proposing ideas for the EU to keep funding your projects, while also battling with the fact that maybe the community that you were in touch with those 3 years might have completely changed their governance structure, their leaders politically, and the fact that maybe they were open or close to having these discussions will change in the next electoral period. So yeah, those could be two challenges.
Yeah. Thank you. I can comment. Yeah, of course.
Thanks. Yes, from a practical example, if I want to say, so European projects with the subjects of wind farm establishments in Black Sea region, so around Bulgaria and Turkey and Romania, where we were involved to doing the social acceptance for that as well. So the local people were extremely unhappy having the new technologies of the wind turbines in their area, onshore or offshore, because they think that it would destroy and affect adversely, lock their businesses and their life there. So they try to organize a few meetings, I think in Sofia, Bulgaria, which ended not to have meetings like this, but in big protests in the streets, because people think that, okay, now you want to come there, you want to destroy our history, our ancient things here, our business there, like, etc., etc. So we went through finding the solutions for that, and we found that one obvious solution could be that if they know that they are part of the solutions and they are consulted from the beginning of the project and even before that, so you ask people to come here, you say that, okay, from 1 year time from now, we plan to put these wind turbines now in your area because we think that it's a kind of a better, cleaner energy now rather than using or bringing things from the gas or from oil, whatever, from far away, which will help you indeed actually because it can create jobs in your area, it brings them some environmental good impacts into your area, you will be part of the enhanced economy now, etc., etc. So they know that they are part of the game, they are taking seriously, even policymakers from different regional authorities can go and sit there and can consult with them, and also to assign things as much as possible to that side. So if you are looking for a construction company, you can see among that specific city or region to see that if there is someone to hire from there, rather than to bring someone from, I don't know, from UK to go and work there. So if they know that they are part of the process from the beginning, it's much more likely that they get involved, and then they will be happy by the thing at the end.
Yes, I agree. Thank you for that. Does anyone else want to comment?
I can comment on that because I was thinking about junior mining companies or junior exploration companies who are operating in Finland, for example. They have learned during the last 10 years or so to engage more with the local stakeholders, and they are openly, all the time informing what they will be doing in the region, whether it's drilling or just some light sampling, but they are constantly keeping the locals informed, and that has been also like softened the attitudes of the locals, which in some places where you have a lot of people out of work, and they are actually wishing that it would be nice to have a mine here because of the new working places. And many of those who are really opposing mining, or they are mining critics, they are not necessarily from the local or even from the region where you are operating or mining companies operating. They come from capital region or somewhere else without any connections to the area. And how do you discuss with these people?
Yeah. In our case, in Romina project, we defined a strategy for social innovation action in 3 different sessions. Since the beginning of the project, we shared with all different stakeholders a questionnaire, and we made a first, after the first year, a first open dialogue session only with citizens, associations, without mining companies, in order to see what is the real feeling. We analyzed the data, and with this data, we integrated in a second dialogue session the mining companies. And in this session, we tried to integrate NGOs, but we didn't receive any answer from them. But now, at the end of the project, maybe in November, we will organize a third open dialogue session here in Seville in order to make a final session together with NGOs. We have some
confirmed already.
Yeah. And then we want to expose what is the real impact of the new technologies in the restoration of the fields. It is known that the CLC Cobre las Cruces is working now in the reuse of the waste to produce metals. But for example, in case of Tarsis, they have a lot of tailings without any treatment. So the idea is to show that the technology we are developing can be a good action for the citizens, for the society.
Thank you. Also, one short comment in terms of engaging with communities. Also, one of the things that we are trying to do within CIRAN is developing a sort of like gaming approach, because I believe sometimes people would not be able to speak up so easily when they are put in like a room and a conversation, even if that's like a small group format, like a focus group, but they would easily react, and you would get their minds thinking if you put like kind of a sort of a game in front of them. I think I saw it in one of your slides that you had kind of a board game, and that would, leave the door open for a whole separate project. But sometimes this is also a good way to engage communities into and develop critical thinking, especially as well for the younger public.
Short comment, because it was actually in Icelander project there is a serious game, and that was developed by BRGM, French Geological Survey, and already for the Mireu project there was a serious game, but this is a new version, and it's exactly what you said. It's a good way to, get in touch with the local community, and you can get the different roles and play that you are a miner or whatever, but there is a good information on Icelander website on that serious game.
Thank you. So I think we have to start wrapping up. I'm afraid this is a terribly interesting conversation, at least for me, but we have the time. I just wanted to say as a sort of wrap-up that as I'm seeing the conversation and how things are going, we are working in Europe like very actively and very strongly towards this sustainability knowledge aspect. But we have to share this information, since mining historically has had some impact and has the image, or has had the image that it has. We cannot fail if we share too much information about what we are doing, up to the level that is possible, of course, but what we are doing, how is it turning more sustainable, how is it reducing impact, how is it making the extraction of the minerals, how is it optimizing it, and then if there is, or if there might be an impact, an environmental impact, what are we going to do to remediate this? And I think that is very, very key. I'm not sure if you want to comment on this, but... yeah, you can.
This is where mine will work.
Yes, it's okay. I think we're going to use that as an alarm, and we can continue the conversation in the networking. Okay, if it's fine with you. Thank you so much for participating in the panel.